So we're going to start off by doing a short presentation, explaining all the key terms about 3D printing, FDM, SLA, and about our printer. So we wanted to make this as interactive as possible. So stop me whenever you have any questions, if I'm going too fast. Yeah, so we'll start the presentation. So a little bit about 3D printing. It's an additive manufacturing process. So we join materials together to form a 3D model. And this is a very good benefit of this is to create complex meshes, intricate internal and fine structures. And you can produce prototypes on demand and have an infinite customization capabilities. It will also decrease research and development costs because you'll be able to create a lot faster. So some application of 3D printing, and that is what we're currently doing: jewelry, engineering, medical, dental, architecture, artwork, prototyping, automotive. And you can see as some of our samples in front here, there's we have a lot, and you can take a look at it once we have time later. So currently, there's two common types of 3D printing: FDM and SLA. FDM 3D printing is using an extrusion head to draw plastic layers on top of the previous layers to create a 3D object. It's inexpensive, has low resolution prints, has rough surface smoothness, and it's very slow. I'm not sure if the picture shows it really well, but on those prints you can see the lines on it, so that's an FDM 3D printing. With an SLA 3D printing, you can use full layers of resin and cure them with a UV light pattern to create a 3D object. You can create higher resolution prints with accuracy and precision, and has a fine surface smoothness and is very fast. So with the SLA printing, there's two types: laser and DLP. Laser is a conventional laser for scanning SLA technology that uses a UV laser and two actuated mirrors to project images to cure the resin. It's very slow because you have a limited surface area hit by a laser beam, and it's 1D, so. It has lower accuracy, is less reliable, and has harder to maintain low resolution prints. And as you can see with the diagram, that's how a laser SLA will be worked. But with the DLP SLA, it's used a DLP projector to project an image onto the resin, the 2D fashion to cure the resin. You can see we have there's a projector within our machine there. It's faster and solidifies an entire layer per exposure to project an image. It has greater accuracy, and since there's fewer moving parts, it reduces the chances of required maintenance, and you can have a very high resolution prints. And that's an image of how the SLA printing goes. Along with the DLP SLA printing, the tiny one has a patent-pending passive self-peeling PSP container. This significantly reduces the separation force between the cure layers and the containers, so it will lead to less failed prints. Enables higher resolution printing, faster print speeds, and large print volume. It's lined with a Teflon film, which lengthens its longevity compared to the other competition. And it's compatible with most commercially available resins. So you're not limited to a certain type of resin.
And I'll pass one down so you guys can take a look.
This is a more technical image of how the PSP works, and you can see with our container itself.
What it stands for again?
Passive self-peeling. Passive self-peeling container, PSP. It's patent pending.
That's pretty much our proprietary separation technology that makes us print faster and minimizes each layer separation force so we can print taller resin. I probably slowed down there.
Oh, yeah. So this is just a slide to compare our Titan 1 to other printers on the market as of right now. As you can see, ours is print a lot faster with a higher resolution, and we have a larger print volume. So we could compare this to a $50,000 printer that's on the market right now, and as you can see, ours is still prints a lot faster with higher resolution and a larger build area. And of course, it's just $3,000.
And one of the key value propositions of there is the fact that you can tune it between 37 and 100 pixels, which allows us to print large. This and also this statue here, they're both printed with 100 micron XY. And we can also tune it to print really small. So jewelry, these miniatures I have a hard time looking at without a magnifying glass. Also for biomedical research. So the blue box over there, you can see the tissue and scaffold, how detailed that is. So with that, we can be applicable to universities, research institutes, obviously jewelry companies, engineering, aerospace, and architecture.
So that was just the boring part of this session. We'll have more fun stuff by having Ted show us how to print.
So before Ted runs the actual live walkthrough from a design file to slicing to having some boards, and then we'll run a live print and show you the post processing. Before that, we want to stop here and see if you guys had any questions for us. I know you guys did a lot of research before you guys came.
So when your XY resolution is 37 microns, what is the area that you can print at that resolution?
Sure. At 100 microns, or 19.2 centimeters by 10.8, correct? Yeah. 50 microns is 96 mm, so 9.6 centimeter by half of that.
It's 1/4 of the area.
1/4, okay. And then 37 is a little smaller. I think it's 7 by 4 cm.
It scales with
the projector.
Yeah, we
right?
can just calculate with the number of pixels.
What is the number of pixels?
This is the projector. It has a TI chip with 1920 by 1080. It's HD.
And we'll move the projector more closer to the build platform for the higher resolution. At 100, we bring it down so the projected area is bigger.
So just so I got it right, 100 microns, you said it's 19 centimeters?
19.2 centimeters.
By 10.5.
10.8. It's 1920 by 1080 by an HD home projector, just a matter of scaling it down.
Any other questions before we?
In your Kickstarter, there's talk about lens modification to get down to 25 micron XY. Is that still an option, or?
Some of our users are doing that option. The downside of that is it forfeits the manufacturer warranty on the projector. But there are folks with, good grand printers, so it's worth it for them to test that. And we've seen good results with it, especially for miniatures and jewelry are the two applications that folks are doing the modification for.
I was wondering what you use that, like the smaller rating of the project, like each project, and then because of the light flow.
Well, why don't we use a smaller projector?
Yeah, I like the reason I make it with light.
Why don't we use a smaller projector?
This is probably the smallest we can find for HD.
The people projector.
Well, the resolution will be good now.
The resolution is good, but the light throughput might not be that enough.
The number
Is it because of like?
It's the number of pixels that counts for the resolution.
There are like 1080 HD
Yes.
projectors.
Yes. So for the same printed area size, you can stuff more pixels, you get more resolution. But the people projector is limited by the chip inside. Usually it's like 1080 by 800 resolution. So you won't have enough pixels for like jewelry kind of application. But printing bigger stuff, you don't care about the resolution. It should be fine. If the power is that's the other problem. Probably don't have enough intensity of light.
Yeah, that's my point. So if you have some limitation on the intensity, so the light should be had
And
like
yeah, this one has like 3,000 lumen. It's
3,000.
Yeah, so if you get the 6,000 lumen project, the more expensive one, the exposure that we have. So the speed highly depends on the intensity of light.
The 60 or 30 hertz. Since the projector, what's the frequency?
Frequency is 60.
So if you can find like
project, faster project, and we can do faster. Does that mean?
Oh, no, in the line has line bulb. We have a stronger line bulb.
So if you can find it like faster projector, like 120.
No, it doesn't have it's not an issue of, when we say faster, right, it has to do with print speed, how long it takes to cure a layer of resin. And that's purely a factor of intensity. Frames per second, these things for like game, that doesn't really make any difference. We're not going that fast.
Any other questions? All right, so that's the fun stuff now.
We use a bowl, gyro bowl. It's designed by George Hart. It has a lot of fun. He designed a lot of, using that, designed a lot of like bowl structure type of geometry. So if you're interested, just download one from this website. And we are going to use one. It's called gyro. So let's assume you have a design, and doesn't matter which design software you're using. But all you need is you can export to an STL file. STL file is the only format that we can process, and later we can create two-dimensional images and send it to the printer. So like a jewelry designer, they like to use Rhino. And we like using Blender as a three-dimensional design software. You can use all of that one free. And I think there are a lot more like free software out you can just explore. And so you have a STL file now. And this small program is called NetFab Basic. Usually it's a free software. We use it to view your three-dimensional model.
NetFab?
NetFab Basic. That's free. And the main function we like is it's a viewer. First of all. Second of all, it can fix your meshes. Simple meshes. Well, I'll explain that later. So let's add this. So this is the ball that George Hart designed. And from NetFab Basic, we would use something in information icon here. It will show you the dimension of this model, XYZ, the size. And the other important parameter is the volume. Before printing, we would like to know the actual solid volume because we need to add more. Like for example, this uses 2.6 centimeters square, and we'll probably add like 40 there in the back. And if you have something 100 shown here, you probably would like to add 120 inside the bag. So this gives you approximate like volume of the liquid resin that you would need to fill inside the container. And the cross here is for repairing. So sometimes you will see there are errors in your mesh. So for this one, it's very clean. It has nothing, no holes, no invalid orientation. All these things are zero, and you got only one share. this is a perfect model. So, and it will help you to fix it if you do the automatic repair. But since this is a free version, so it won't repair everything. If you have something more complicated, you will need to go to their cloud version. It's called NetFed Cloud. You can search it. You upload your damaged file, or the file need to be repaired, and then just take a while, and then you can download it back and it fix for you. That one, the cloud version is more powerful for repairing meshes. If the meshes is not repaired, you will have problems. For hollowing, you have a statue, want to do the hollowing, you have problems. You will have problems by slicing. You will create something unexpected when you do the slicing. So make sure you check your model, the integrity of your model before you do the hollowing and slicing. So this one looks good. And so next, what we like to do is we want to add support. So for all these models, we can just import to the printer, slice it, and we won't do. It's like building houses. Each model you have to build it from the foundation. So we need to add support and layer by layer and build it up. So next, and the software we use is the party software called Resin Workshop. You can download it. Their website is Resin. Let's see. Resin Workshop. This one. So this is the software we use for slicing, and we could use it for layout. We use it for generating supports. So you can download this program at the bottom here. And this is a free software. Okay, let's run it. Okay, before we import the model to be printed, we want to make sure you have the right size of your projected area. So it corresponds to the right resolution you want to print. So let's say the model here. The model here has a size of about 5 centimeters, and we would like to use a projected area slightly larger than this one, so you could have as many pixels as possible inside your model. So you can print the same object with 100 micron resolution. You can print this object with 50 micron resolution. It's just the projected area that determines the resolution. If you have a question, please just raise your hand. So here I would like to use a projected area slightly larger than this one, so you get more resolution. And for 50 micron resolution, as we just mentioned, the projected size is about 54 millimeter by 96 millimeter. So it's enough to put this bulb inside that area. Okay, so now let's import. Okay, this one. So when you import it, probably will sit right in the center. if this is symmetric, if you
Here's the question. Yes, if you're going to be printing it at 50 micron resolution, does that also mean that at some step you're going to have to adjust the distance of the projector from the back?
Yes.
Sorry to jump in.
Yeah, sorry. We make sure the projected area size on top of the back, the bottom of the back.
Okay.
The size will match that, has to match that. So if the model is symmetric, we will sit right in the center, like this one. But sometimes you won't, so you can adjust position by moving it. If this is moving in the X direction, Y and Z. And we need to add support. So before adding support, we always have to let the whole model. And usually we would do like, let's say 2.5 millimeter. So we will leave some space below the model for the add supports here. And for this version of creation workshop, the plus sign here is if there's a panel for you to add supports. It's called support generation, and you can add it with manually or automatically. But the automatic support generation never works very well. So up to now, I have found no software that can give you a satisfied automatic support generation, unless your structure is very, very simple. Maybe it's just a flat plane or with a little curvature, and that could work. But something complicated like this, or you have like figurines, probably won't work. And so to manually add this, we can first we have to assign a shape of your support. The shape looks like this. And there's a tip size, and then gradually going up, and the bottom is the largest. It's like a building a bridge, you need pillars. So usually we would do, for this one, we would do like 0.3, 0.5, 7, 0.9. So
how do you determine how much support you need?
Depends on the size of your model, and depends on the structure of your model.
Right, but so the software wouldn't tell you whether it's enough or not,
Software
right?
won't tell you.
You just need experience, basically.
Yes, you need to try it. And we would like to have a smaller tip, so after you cut it, it won't give you a scar, a large scar.
So 0.1 is too little, it's not reliable? You increase from 0.1 to 0.3, so 0.1 is not reliable?
No, it won't work, because it's so tiny that when you level it, it's going to break. And for this is a smaller object, if you print something big, this big, you probably have to increase to 0.4, 0.5. This is the radius. So times 2 get the diameter.
This is one of those areas that is very hardware specific. And so automatic support generation, generally similar to an FDM printer, figures out where you need support based upon the angle of the overhang. But for this printer in particular, angle of overhang is very, very crude, because this DLP SLA printers like this can produce perfectly flat overhangs. I can have like 2 posts and bridge like 10 centimeters, no problem, right? With a roof that's totally a 90-degree overhang. But then other things, depending on features, a 45-degree overhang might be a challenge if I need good part shape. I want to make sure that a particular 45-degree angle is perfectly straight. That might need support structurally to keep it straight. And these are things that are very much printer dependent, and that's why, like Ted said, right, you need to kind of hit it with some manual touches, because only you know exactly which parts of your print require certain types of features, and then which parts of your print are designed in a way where you don't need supports.
I can show you the difference. Just looking at this for you can tell we need to add supports at the cross sections. But if we do it like automatic, let's say this one, it has a gap. Let's do this adaptive versus adaptive. It has a gap of 5 millimeters. When we press the automatic button, it'll give us a lot of support. It'll give you support like penetrate going inside.
It's doing it.
Yeah, it's generating. It has to figure out, because this model has a bunch of interior space inside, right? So there's a huge amount of greater than 45-degree angle vertices on the inside of this sphere, and so it's trying to find all of those. Now it turns out that we know that we don't need actually all of those to be supported, because we have a really excellent ability to have unsupported overhangs with the DLP SLA printer. But it's still got to search. Whatever number you enter in for that angle, it's got to search those. So this is somewhat of a computation intensive process.
Yeah, so
there we go.
to the simple one, it's better than else. It won't give you a lot of calculations. Just give you like the periodic type of support, and it'll put it anywhere it found. So so a lot of time we will simply just put the manual put the supports ourselves manually. So for example, we can this is for manual support, and then we click it. It should give you a support at the specific location here. And this newer version of Creation Workshop will give you a bended support instead of straight. We could add another one. It's something like that. So sometimes it's not enough, just adding supports here. We have to export your whole model out using this save as an STL file, and then you have to open it with your editor. Right? We use the Blender, and the reason is, for example, if you want to print the figurine, like with a head, with a neck, you need to put a support under your chin, and there's no way you can do it here. So, and those kind of supports that doesn't touch the ground, you have to do it outside. And we have seen programs that try to generate supports like those very strange areas. Usually will overdo it. It will give you a lot of support, and it's not clean. And the program wants to make sure it's printable. And the end result is you have to cut all of this, and it leaves a lot of scars. And okay, I'll show you the one after adding the support. This is the one that's printable after adding the supports. This was done with earlier Creation Workshop that gives you like straight support. It's all straight like spikes. And before printing, we need to add a so-called attachment layers. So that's the most important layer for doing the SLA printing. Every printer is that. And the purpose of doing that is you want to have a pretty tight adhesion between your model and your platform. And occasionally, that if your the attachment is not strong enough, your model could drop during printing. And with this, the center icon here is the is a attachment layer, base layer generation that gives you one layer, one thickness, and it is 1 millimeter thick, and that is too thick for SLA type of printing with 1 millimeter thick. Your model will probably drop because of shrinkage. So there's a 1 millimeter thick plastic stick on your platform, and during printing, it keeps shrinking itself. And corners will bend, and if it's bending too much, your model could just drop. So that's why we always limited this thickness to about 0.25 millimeter to 0.3 millimeter. So for these layer, usually we just drop it, just click it and drop, lower it. So 3/4 of it will stick below the zeros, Z0. When you slice it, it won't give you any layers. It will slice from the Z0. So the effective thickness will be 0.25 millimeters. So just remember to use in Creation Workshop. For slicing, we would like to check the configuration. If you click this tab, there are two more. It's configuring machine and configuring your slicing. So for the machine part, I want to make sure it matches your projected image. So this is an important part here. The X is the projected size of your longer size. The Y is the projected size of your shorter side. It's 96 millimeter by 54 millimeter. That indicates 50 micron X and 50 micron Y. And for the Z, we usually put 257. But the maximum printable size is 252. Since you always leave a gap, so you can move up and give it a separation. And click the apply here and make sure the resolution, number of pixels is right here. And the resolution 50 micron is right. And then move to the slicing tab. For this bowl, since the resolution is pretty low and we want to print it quickly, we do the 0.25 millimeter layer thickness. And usually for printing rings, we do like 0.05 or 0.035. 50 or 35 micron. But this one, it's a low resolution printing, we do 250 millimeter to speed up the process.
Will it give you warning if that's you're trying something finer than your printer's ability? If you enter 0.001.
0.001.
Right, but the program wouldn't warn you, right? It would just
the resin has a limitation.
Right.
The best resin can do is 0.025.
That's correct. The program doesn't know anything about the physical limitations of your printer. So the program, you can enter any values you want here, and then when you try to print, who knows what's going to happen.
some applications like ZBrush can sculpt in millions of polygons. Does this application have a limit to the number of polygons they can process in order to do slices?
Oh, for this
Yes.
creation workshop, yes, there's a limitation.
Yes, there's limitation. I don't know what it is, but I know that this guy here has a very complicated network of supports on the inside that you can't see. It has about 150,000 triangles in it. It definitely struggles to keep up. I got it to work, but it struggles a bit. There are other more commercial applications like materialized magics, which is used in professional SLA. And those can generally keep up to almost an unlimited number. So if you have a couple million, you might need to move to pro software rather than open source software.
So this software, you would say the limit on polygon mesh would be about 100,000.
Well, this I said had about 150,000 triangles in it, right? So a couple 100,000, you probably could get by. If you had a powerful computer, right? This I did on my laptop, right? You more powerful computer, more memory, you could probably get bigger, right? I think, you know, the multi-millions, I think, would be a challenge.
Yes.
You usually won't take like a file size larger than 100 megabytes.
I'm sorry, how many megabytes?
100 megabytes. You won't take it. It also depends on your hardware. If your computer is powerful or not. And sometimes we do like printing whole plate of rings occasionally. So we actually will replicate one single ring on the whole platform. So if one single ring is 10 megabytes, you have 10 that's already 100, then you probably get some problems. So apply the changes, make sure the slicing configuration is right, and to check the reflect one here to make sure it's what you want, it's not the image version. And then just click this button, and it's going to slice. Sorry, we have to check this. And this is going to give you like a two-dimensional PNG files in a folder.
Which slide?
It's not right. You have to click apply. It's not slicing the images. This one.
I think you need to turn on the export SVG also.
Which one?
Export SVG. Yeah, it's filled. Yeah. And apply. Oh, we have to save it first.
Okay, it's slicing now.
That's pretty slow.
Yes, so it's pretty slow. If you want to do a lot of slicing or complicated slicing, then you probably need a CPU 4
No,
core.
but this is unusual. I mean, this laptop here, I only slice it this slowly if I have anti-aliasing turned on. This is really slow.
It's really, yeah.
this 10036 or 10054?
I mean, this version.
Yeah.
This is the most updated one. I don't see much difference except that the support the shape of support.
Well, there's a lot of quirks between the different versions. 5.4 is the most recent version, and it generally works the best, except if you use anti-aliasing, which is more advanced. Then it runs out of memory. It takes exponentially longer. There's a lot of bigger models you can't slice. Then you can go back to 10036, the earlier version. Anti-aliasing works better there, but it's less stable. When you're moving the part around in the older version, it could just crash randomly while you're moving it. Whereas in this version, it doesn't good. There's no crashes. Some people have. I have mostly straight wall parts. It doesn't really make much of a difference. So I don't use it anymore for my straight wall parts. It doesn't make any difference for that.
We never used this, and I can tell much difference.
There was a lot of activity for the software for people with DLP projectors, finding that it made some difference. It's hard to say. At least for me, since I'm printing big stuff, I don't notice.
So they say it's better quality, better resolution, or what's
surface finish, surface quality, is better. But there's a lot of factors for surface quality. Your focus, where you're projecting. So it's hard to isolate any one factor, or you have to be your full-time job. And I already have a full-time job for you to go and isolate individual factors and try to figure out what their effect is.
Well, let me show you the end result.
So is the result going to take much more disk space than your input?
No, well, it might. It depends on the complexity of your input. If my input is like 2 gigantic triangles, or it's more than 2, like 8 gigantic triangles, then yes, this output will be much bigger, because these are sliced images you can see here. So this is purely the size of your output is going to be a factor of how tall and how big your image is. Mainly how tall, because that's the number of images.
It's just black and white.
Yeah.
And you usually will go through this license before printing to check for your printing parameters. So your printing parameters depends on the shape, depends on the exposing area, and depends on the structure of the model. So it's better you go through this quickly.
This is particularly important if you've imported STLs from ZBrush or Maya or something like that. Because if you have any non-manifold geometry in the STL, the slicer will still try to slice it. And then when you look through this, you'll see really strange stuff, like random straight lines through the part, random negative lines through the part, where every place along a line where there was supposed to be something, it's been cut off, right? And this will translate into really strange results in the print, where you'll have mysterious holes, and where you'll have like garbage floating around the vat or whatever. And so you have to be careful with the non-manifold geometries with the STL, the cleanup step that Ted did in NetFab, because that won't just show up as, oh, Creation Workshop failed, right? It won't fail necessarily cleanly. It'll try. And then when you take a look at the slices, there'll be really strange things in there.
And sometimes we can also find out missing supports through this.
Yeah.
So yes, that's it. Before sending to the printer, that's all we need to do to create all these slices. And the projector will show it like one after another to create cured layers on the printer, and each layer would stick to the top and get separated from the bottom, and they stack one layer after another, and like pulling it out from the liquid resin. And John, you want to show the process?
Sure. go ahead and do a live print.
Is there a question?
Yeah.
Is there any software that can take these PNG files and kind of assemble them to kind of tell you what you would get and make sure that the other software is kind of doing what it's supposed to do?
No, you can't really turn it back into 3D. The best you can do is take a really fast image viewer. I use an image viewer called IRFan View, and I just hit the forward button and watch it as a movie, and try to see if there's like mysterious things that pop out of the middle of nowhere. Everything needs to be connected to each other. You can't have suddenly, a square appear in, layer 25 out in the middle of nowhere, because that's not connected to anything and that won't work. And so I watch it as a movie to see if anything obvious pops out. And the first time, right, in small ones, you might go one by one. But after you've done it a couple of times, you kind of know what to look for. Want to turn the lights back on?
Maybe after.
After?
This.
Okay. So what resin are you using?
So we're using the G+ resin. Actually, it's a good time to maybe stop and show some of our prints for folks who didn't get a chance yet. So for the G+ general purpose resin is what we use for these larger prints. It's more affordable. It's about 55 for a liter. And we have resin for higher resolution prints. These miniatures here are done 37 microns.
You want to turn on lights? Or?
Yeah, now we can turn it on.
You guys can pass it down here. These rings here are using a ring castable resin. So this is a ring after casted. This is using silver with a process called gloss wax casting. Cast resin is the most expensive. It's about $200 for
Prematurely.
And actually, another pretty cool application is, and you can use a couple of resins. The spot HT for the high resolution works. The ABS resin works as well. These two have vulcanized miniatures. These are really small. There's some over there too. You guys can change it. And for functional use, we have ABS resin. So this is really tough. And there's one right there as well for mold and for more functional use. This is a screw right here. We're actually able to print threads for a screw with 1.5 millimeters. So it was really useful. That was for a person's thesis first PhD program.
It was a 1.25 millimeter pitch.
1.5 millimeter diameter. So we pour the resin in. We have to zero the build platform. And so I'm going to bring the build platform down to the bottom.
I think I have some examples of printed screws, not M1.5. The smallest in my setting is M3, but they're in a cup somewhere. There's a whole bunch of them if you want to take a look.
John, so do I understand correctly, this is the original detailed resin, and then they did a silicone mold and then cast this?
They printed with our resin, right? And then after that, they can directly do
They create a mold using vulcanization. So what you do is you buy these slabs of natural rubber, and then you clamp the piece in it, and you stick in the oven, and then that will melt out cast. It's similar to RTV silicone, but you use this this vulcanized rubber when you want to pour metals, hotter stuff, particularly like the pewter tin alloy there. They are commonly done in vulcanized rubber. And in order to survive that process, the 3D printed component needs to be strong enough to resist the pressure that's generated by the vulcanization process. And that 3D MABS is good for this purpose. There's a couple of different resins that will hold up, but you've got to hold up to the temperature. Most people do in their ovens, like around 350 Fahrenheit. So it's got to stand up to the temperature and to the pressure of being clamped in between the two rubber halves.
You're going to cast something in resin. Do you know if this is reactive to silicone casting rubber?
I mean, almost nothing will work with a platinum catalyzed, but I'm betting with most like tin catalyzed silicones, it'd probably be okay.
So I'm gonna start running the print now.
Right. Okay.
Feel free to also move closer if you guys want to take a closer look.
Yeah. It's the first layer. Okay.
You didn't get to show your software though.
Okay.
So this is our control software.
So in the beginning, you mentioned alignment. Is that a manual process or auto process?
Oh, that's a manual process. It's relatively simple. You have to level the printer.
Oh, I saw those two. Yeah.
Yeah, so you've got 4 feet. You got to level the printer
Yeah.
because otherwise the resin will all go onto one end, and you got to fill it up really, really full to get it in. So you want it pretty level. The more level, the better. Because if you have it really level, then you could put in as little as like 40 milliliters to print something small.
Yeah.
If it's really tilted, you're going to need to pour in a lot more resin to print small parts.
So after it's get printed, it's recyclable. The rest of
No.
the things are wasted.
Resin is not good for the environment.
Yeah.
You have to be careful with the disposal. Cured resin is pretty much regular trash. And cured resin is not toxic. It doesn't react with anything. It's not dangerous to fish or wildlife. Cured resin is pretty unreactive stuff. In fact, that's one of the really good things about using resin is compared to ABS or PLA, resin is very, very chemical resistant once it's cured. It's also very temperature resistant once it's cured, because it's not a thermoplastic. But liquid resin is a hazard to fish and wildlife.
Oh.
And so if you have any uncured resin, you got to make sure to cure it before you throw it away. So for instance, all my scrap parts and everything, I gather them up in clear plastic bags. And before I throw it away, put the plastic bag outside in the sun for a couple of days. And then it's fine. But generally you want to, there is going to be a small amount of resin that ends up going down the drain when you clear up, right? It's all about getting as little resin as possible. Liquid resin in the environment. Solid resin, not so big of a deal. Liquid resin you want to keep out. It's not super horrible because liquid resin does not mix with water. So it doesn't float to the top the way that oils do. But generally it's not good stuff because liquid resin is quite reactive. So liquid resin will eat ABS, for instance. If I have ABS plastic and I poured liquid resin onto it, it would melt the ABS like acetone. And liquid resin, in general, you want to just keep it away from stuff, your own stuff also, because it would eat this plastic. It's pretty reactive.
Yeah. I see. So say if you put a lot more into that container and get it down, so you consume like 10%. What do you do with the rest of 90%?
Pour it back into storage bottles. So that's what you see. I brought some out my own. You'll notice that these are not original. These are bottles that I bought. You pour them into storage bottles. You would need them. Glass is okay, or I guess polyethylene. The only stuff, HDPE. So no LVD, no ABS, no PET. It actually can be a challenge to find the right type of bottle. The glass bottles are by far the easiest to buy. Yeah, you can for $24 you can get 12 on Amazon. So it's pretty easy to buy the glass ones.
So what are in the bottle? What's in the bottle?
Resin.
The resin.
Resins that I've used before and then stored in separate bottles. Yeah, you need brown glass. Amber. They sell those amber or brown glass.
After printing, do you have to wash the
You try to avoid using alcohol as much as possible. These vats are made from acrylic. Acrylic and alcohol don't get along. Now this is high quality cast acrylic, so it can withstand alcohol. It won't crack. If you use pressed acrylic, and I don't know if you've ever seen it, if you buy like really cheap acrylic sheets,
from Home Depot, those you can't let touch alcohol, otherwise they'll craze right away. This is higher quality acrylic, same grade that you probably find in like tap plastics in various sizes. That can touch alcohol, but alcohol is not good. I try to use as little alcohol as possible. Regular like Dawn dish detergent is enough to clean the utensils. So generally, I only use alcohol maybe 1 out of every 10 times I clean the baths. Not to get rid of the resin, but because there is pigment in the resin. And over time, the pigment will stick to the side. It's hard to get off. And I'll use alcohol to get rid of any stuck on pigment, particularly if I'm switching from like black to clear. Then I might shoot any specks of leftover black with alcohol. So ordinary resin cleaning, dish soap is sufficient. It is a little weird. I've got a video on YouTube that shows the cleaning process. Dish soap doesn't clean resin the same way it does like grease or oil in your dishes. It won't emulsify the resin. What it does is you're really using only the surface tension effect, the protective effect of the resin and of the detergent, and it causes the resin to bead up much more easily than it would on just water. And then it becomes easier to sweep it off and rinse it away. And so it's a little bit weird to begin with. At first, I used a lot of alcohol on my first bath because I really didn't feel that the dish soap was getting clean. But over time, I tried to use less alcohol.
How long do the bats last? Is it consumable or?
It is a consumable item, right? And so I have bought in my lifetime. I've bought like 10. All right, but they last a long time unless you do strange experiments on them, like I have. A bat should last more than 100 frames. So long as you don't make a mistake and do something that breaks your bat. A couple of things that'll break your bat is if you print unattended and then find that you didn't lift enough. If you watch this, you see there's a cycle that it's going through right now.
Yeah, no, it's
It's going to lift to try to release, right? And it's got to lift high enough to pop the part off the bat. If you don't lift high enough to pop the part off the bat, you're going to re-expose the same layer against the bat. If that happens after a while, it can make the part successively stick to the bat more and more. And then at some point, you may be sticking so strong to the bat that you rip the film. There's a film here that sits on top of a layer of silicone. You might rip the film off the top, or you might break the bat. You probably won't. You'll probably rip the film off. And a lot of people in the early Kickstarters, we didn't know that much about it. There are a bunch of people who ran into problems where they burned through bats like mad because they were lifting off of the silicone.
Did you make a mold?
I didn't make that one. But yeah, no, this was done. What John said is this was made with vulcanization. That means they printed this part in positive, this shape, and then you sandwich it between 2 pieces of rubber, clamp the rubber, you put it into the oven, put it in for a couple of hours, and then the impression is in the rubber. So you made a mold out of it, and then this was cast in that rubber mold. That's right.
Took the 3D printed part out.
Took 3D printed part out,
Back together.
and then you put it back together, and you poured metal in. Yeah.
This kind of metal is very low melting.
Yes, if you need to get higher metals, then you have to get into lost wax. There is a type of resin that is designed for lost wax, for higher temperature metals. Yes, but then those are only one-time use. For lost wax technique, you get a burnable resin. There's low ash resin that will burn out cleanly. When you say burn out, it doesn't mean that you light it on fire. You have to have a special kind of kiln for it, right? So this is for like professionals because you have a special kind of kiln that can burn out, that has good temperature control, so you can cleanly burn out the material. But what you do is you put plaster or whatever around the part, then you burn out the part, and then you pour the metal in, and then you break the plaster, and then you have the part for one-time use for heavier metal.
What kind of metal is the highest temperature?
If you're using sand and plaster, you could cast anything that you have the equipment to melt. Right? Like you could do aluminum relatively easily using cobalt stuff. If you watch any of these YouTube videos of backyard aluminum melting, yeah, steel. I mean, with lost wax technique, right? Whatever you need to make your mold out of, you can make your mold. You're only using it once. So you don't worry about it. Yeah.
What is the
That is part of the secret sauce that makes these vats way better than almost any other 3D printer out there, at least in my opinion as a user. Most 3D printers, if you got like a Form 1 or something, you don't print on this film. This is Teflon. You print on silicone. And silicone is less sticky than Teflon by a significant degree for 3D printing. Not because it's smoother, but because it adsorbs oxygen or air. So it holds molecules of air on its surface because its surface is not super smooth and super hard. And that supercharges and inhibits. Right. I mentioned before there's 4 chemicals that go into resin, right? And in particular, there's the initiator and the inhibitor. The inhibitor stops the resin from curing, and the inhibitor is fed by air. Right? So the initiator is fed by UV, and the inhibitor is fed by air. There's tons and tons of air available. It makes it supercharges the inhibitor. You need more UV to cure it. There's less air and more UV, then you get harder. Having this layer of air that sticks to the surface of the silicone supercharges the bottom layer of inhibitors in the resin. And that means that it stays liquid, doesn't solidify. And that makes silicone very easy to release from. Right? The bad thing is that silicone is an order of magnitude not as tough as Teflon. Right? Teflon is famous, right? It doesn't react with anything, right? It's really smooth and pretty good temperature resistant. So silicone will react with resin over time. And your silicone will start to show signs of chemical reaction after as little as 1 print. As low as 1 print. And depending on the way you orient the print, you could consume your vat, make it unusable after just 1 print. If I printed this guy, I printed flat on the bed, right? And that means the walls here, same spot is exposed 450 times, right? On silicone, that would pretty much be the end. Same spot, cured at max high intensity, 450 times in a row, you'd be done. Normally, on a silicone bed, you would always print this at some angle so that this wall gets spread out along the surface. So you don't get a single area getting all of the cure all at once. Spread it out. And that makes silicone last longer. With our Teflon films, we don't worry about this. It doesn't make any difference. Yeah, probably. This was flawed to begin with. For no They sell them in all different kinds. I don't know that Teflon is not clear to begin with. I mean, Teflon in the form of tubes they sell for 3D printing, for FDM printing is white, but they sell the Teflon sheets.
So anyway, the projector is exposing the resin the resin is stuck to the
That's right.
All right, so it pulls all the way out of the resin.
What you want, you need to pull high enough that the surface area of the part completely releases. That way, the amount of new resin flowing in under the part is uniform, right? If you look at the way that lifting works here, you have to watch this carefully, right? You'll notice that the vat is only secured at one end. The other end is free. Because sticking is a vacuum, right? And so we do better with releasing the vacuum by getting some shear in, right, with the flexing of the vat, rather than trying to pull it straight off the top, right? And the flexing of this vat helps get some shear in so that you're sliding it, right?
Back is what?
What?
Back?
Vat.
Oh, back.
Right. And that's why this vat is flexing as it lifts. And that helps release the part. But it does mean that the part does not release all at once, right? It releases gradually, and if you had a really big part, right, that's long like this, I would only need to lift like 1 millimeter to get one end, and then I'd probably have to get to 7 millimeters before this end here finally comes off. So you need to be lifting enough to release depending on how strong the part is sticking. Just come up with fill. It doesn't matter whether it remains underwater or not. Yeah, if it's under the pool or not, that doesn't make any difference. It does make a small difference if you have a lot of bubbles in the resin. Because if you're pulling all the way out of the resin and then you're pushing back into it, you'll be pushing air back into the resin. If you're using a really thick resin, you might have problems where you introduce air bubbles in. With this much resin in the vat, it's not really such a big deal, right? Because bubbles are going to float up at the surface, right? Meanwhile, you're printing way on the bottom, right? And that's a big distance for the bubble to travel, right? The bubble doesn't want to go down, right? But if I were printing a small part and I put the minimum possible amount of resin in, right, where I only had like 1 millimeter of resin at the bottom, right, then yeah, I might have more bubbles. Right. What if you're printing for the purpose of the part? The solution is easy. Put more resin in. Put enough resin in, the bubbles always stay at the top, right? No problem. Size of the vat doesn't really make much of a difference. Yeah, you put it back just like you get some bottles. Well, so this is an interesting thing. This is the difference between my experience and the traditional rule of thumb. Traditional rule of thumb is you need fresh resin mixed in, and resin that has gotten some side exposure doesn't perform the same as fresh resin, and that means your settings will change. It may become more viscous. You have to add more fresh resin in to refresh something. I haven't found that to be much of a difference at all. Part of it is that there are some features of this printer that are different than that of traditional or of other 3D printers, like the most one that everyone knows about, the 3D, right? And the Teflon is a big difference. Teflon means that the vat surface is chemically indestructible. When I print on bare silicone, I mentioned that the resin reacts with the silicone. The resin especially reacts with silicone when you're shooting light at it and the photo initiators are acting, right? So while the initiator reaction is going on, that reaction is going to catch the silicone. The silicone will also undergo chemical changes, right? And that means you want to be careful not to cure too much, right? You want to cure the minimum necessary to make your part conform, but not any more than that, because you want to save the life of your vat. Our film here is virtually indestructible. It will not be chemically harmed no matter how long I shine light into the resin, right? And it's in contact with reacting resin. I have a different concern, and that is my film does not release as well as silicone. So the harder I cure resin, the more strong the resin will stick to it, and the more I'll have to lift harder, or I might damage the film, right? But my window there is oftentimes much bigger, meaning I can, if the resin say takes 3.5 seconds to cure a layer. If I go to 6 seconds, 8 seconds, not a huge difference. If I go to 14, 15, yeah, it's going to get hard to release. I'll notice it, right? But I have quite a big, like 100% exposure time leeway on film. Silicone, every extra 1/10 of a second takes your life down, right? You just want to minimize the amount of extra exposure because all of that consumes your back life. Right? Yeah, you could have an accident, catastrophic accident, like the film gets pulled off. That won't happen over time. That'll happen all at once because you made a mistake. If you don't make a mistake, it won't happen, right? Mistake meaning you did something that got the part really, really, really stuck onto that, and when you lift it, you pull it off, right? Because silicone is soft. Every time I clean, I use a squeegee. That's going to push the film back onto the silicone, right? And so that mostly isn't going to build up over time. But it'll be a catastrophic accident, and then you'll be done. Other things are the silicone over time will get roughened up. No, sorry, the Teflon will get roughened up. And as the Teflon gets roughened up, it will stick more and more. That's where the vat construction also, resin is really reactive. The vat is made out of a couple of different things. If you look at it, you'll see that it's got soft filled sides, right? And that's a unique feature of the vat, is the film sides, because the vat needs to flex, right? Because when we release, we don't want to just pull the part off the top, right? Because then that will produce, we'll have to counteract all the vacuum force all at once. We want to peel it off, right? So we're holding it onto this side, and it's lifting, and that's going to cause the vat to flex, right? So this film is really important because the film allows us to flex in this direction. The film is not as chemically resistant as the acrylic, right? The acrylic is pretty impervious to resin because resin is a close relative of acrylic, which means, in general, fully cured resin is mostly impervious to what's uncured resin. This acrylic is also pretty impervious to resin. The film and the sealant here is not. And this stuff, depending on the type of resin you have, will chemically wear. This one is a very thin film. The 3DM resin that was used in vulcanization in whatever that orange part was, that stuff is very, very reactive. It's so reactive that it cannot be printed on silicone. So only 3D printers that use Teflon floored mats can print in that stuff. That stuff also attacks the film. So there are two kinds of vats that they call the V1 and V2 vat. I have a lot of that, so this is a V1 vat. I can tell from the feel of this. This can't be used with that 3DM material. That 3DM material won't use through this. They have another version of the vat that has a thicker sidewall. It's still flexible enough, but it's thicker, and that withstands the 3DM. But there is a lifetime for that wall still. It's measured in hours. It's something like 100 or 300 hours of cumulative contact. And so with a less reactive resin like the Maker Juice G+, my lifetime is mainly number of layers, surface, right? And if I want to, I could leave the resin here forever if I want. I don't want to because resin there are components in it that will evaporate. The resin will still work, but then it's not quite the same. It's a little thicker, strange things can happen to it. But that's not the greatest storage medium. I'd much rather have it back in the bottle. But the 3DM resin, every minute it's in the vat, you're counting down time on the sidewall. And so that one, they say, you really want to clean it up as soon as they're done, because every second the resin is in there, right? The life of the vat is counting down.
No, it's not.
I have no idea. You can ask Ted; he might have seen this before. I've printed very, very little 3DM ABS, so I have no idea. Oh no, the non-3DM resin won't be the sidewalls. No, whatever chemical is eating the sidewalls, these other resins don't have it.
So I'm still trying to understand the thickness. So you have more resin than the thickness of the layer, right?
Yeah.
And it looks like it's even lifted up or like a builder forces or something as you lift. So when you expose the light, why all that resin that above the layer doesn't become?
Oh, because the resin has pigment in it, and so the resin should only carry light to a very shallow depth. And this is a big...
So the thickness of deposited layer is pretty much determined by the resin?
No, the thickness of the deposited layer is primarily determined by the distance between the previous solid layer and the bottom of the vat. That's how much resin is getting in there. But if you have a gap...
Yes, that's a different question.
You can either leave it off at the side. If you have a gap, like this part here, right, has a bunch of stilts, right? So light shining in here is going to go through. That's then the amount, we call that overcure. And the amount of overcure you have is dependent on the opacity of the resin. And the opacity of the resin to specific wavelengths, particularly violet and higher. Violet is ultraviolet. So our projectors put out mostly, around 400 nanometer light, right? Resins are reactive generally from 350 to 420. And we want to block that. So this guy's pretty well blocked. You can see that he's on stilts. You can see all the stilts. This guy, not so much. Where are the stilts? They're gone, right? Because it's shot through, right?
But so if you did this at a thicker layers, then it will be less of this effect, or no?
It got through 4 millimeters. That post is 4 millimeters tall. So I cannot do anything about this problem with a part like this, except by changing my design so that I don't have those types of features, or by adding some type of blocker, something chemical into the resin. I can't do anything about that in settings. Exposure time,
getting color.
Yeah, by adding color into the resin. But I might have to add quite a lot. I was doing experiments. This is a lot more color. It's only marginally better. You can see the wavy edges here, right? So it's a little bit better, but not by a lot, right? But there are chemicals we can add. For instance, if you look at this part here, this is 3DM ABS. You'll have to imagine, but you'll see the post did form, right? And that is definitely more clear than this. And so it's not so much visible light, but
Is it? I don't know how this will look like.
This came out, I have to take my word for it, this came out just as good as this.
Oh, really?
Yeah.
But why now it's polished out?
Because there is still some overcure. This surface is about the same as the back end surface there. The reason why it's so different, you can't tell from just looking at it, but if you shine a laser into it, you can see the big difference between the way the laser light carries through this and the way the laser light carries through this.
What's the difference? I don't know.
Oh yeah, look on the side and see how much laser light is coming out the side. Right? Compare that to this.
Oh, okay. Yeah.
Right? And that's that more than the darkness is the big difference. Right, and so there's a UV blocker in here. I don't know what it is. I don't know where to buy it from.
I guess, kind of feels released when you.
There are odors, definitely. There's no volatile organic compounds, no VOCs. We don't use any organic resins here, organic solvents. But there's definitely this is all acrylic chemistry. So if you ever use acrylic paint, it's the same type of polymerization. And yeah, it'll give off some odor because there are some solvents in there. It's pretty mild.
The other question I have is, when you make the ball like that, at one point, the start of sticking surface is smaller than the one that you are building.
Yeah.
So there is a danger that when you put it, how come the top one doesn't pop off before the bottom?
Because it is a danger, but it's not purely a function of surface area. Resin, because the bottom, the back part is Teflon, right? Resin sticks much better to other resin than Teflon by several orders of magnitude, right? So even if the surface area from one layer to the next gets bigger, you can often survive that because the resin still sticks better to the previous layer of cured resin than it does to Teflon, right? Because Teflon is pretty non-sticky stuff. But eventually, whenever you have a big change in surface area, there's always the risk that the change is big enough that you will either pull off the bed, right, the attachment point of this part that's sticking to the bed, or that you'll exceed the interlayer adhesion. You're less likely to exceed the interlayer adhesion. You might break something. Right? So I tried to print this whole thing on one post. It's not an issue of interlayer adhesion. It's just not strong enough. It's going to break off, right? If I try to print a pyramid upside down, right, that's not a very good. That's not going to be very good because only the tiny tip is going to be sticking to the bed, right? There's some things that you can't do.
You
do. It affects your orientation. It also affects oftentimes your layer settings because if you expose a layer harder, then it has better interlayer adhesion. Then you have a better chance of surviving a layer change. An example of this is there's a flaw here. This should be perfectly flat, and it's not. This part here is warped. That's because there's an internal structure here, right? That's holding up the roof, and there must have been some detachment from the internal structure. The internal structure failed, and so then the pulling forces warped up this surface, right? So it wasn't fatal to the part, but it wasn't fatal to the print, but the part is unusable because of this, right?
So there are it doesn't break the layers. It breaks the you cannot really on this thing. I cannot even see the traces of the layers. Perfectly smooth.
No, but you can see it on the side.
Yeah, on the side I can.
On the side you can.
On this.
Yeah, because to some extent.
They polymerize completely beyond the.
The resin acts as a light pipe, right? Even if I have a lot of resin in it, a lot of pigments in it, it'll still act to carry light across, and that'll help the layers, especially as you build more layers on top. The layers adhere together better. So the internal layers, because a lot of light has been carried into it from subsequent layers. Yeah, this is pretty strong. You'll see that it cut this way rather than across a layer, because it is one solid part. But this partly is only because there have been many layers that built on top of it. So it's been exposed to a lot of cure through, right?
So if it were very curved,
if it's very close to the end here, then you're more likely to see artifacts. You can see that there's an artifact here actually from the pull.
So it was peeling?
Right, some peeling here.
So this was exposed to some external usage this part?
No, this was damaged. I never completed. No. It didn't. It had a flaw while printing. the supports that should have held this solid broke off on the inside here.
So it was damaged during
printing. Right? This is a failed print where it still managed to come out, but the feature is not right. The feature should be like this. And I fixed it, or I managed to get the second one to print correctly by increasing the exposure, right, of the internal layers, so that it would hold on more strongly by a substantial amount. I think this one had like 4 seconds or 6 seconds of exposure in between, and this had 14.
In terms of, you said they shrink after. So what's the minimum shrinkage that?
Every resin is different, and it's very difficult to quantify because different manufacturers rate their shrink differently. Some of them rate them volumetrically, right? So, and some of them do them rate them dimensionally.
But that's spectral.
Well, I mean, a lot of it depends on fillers. It could shrink. You might find shrink as big as like 10%.
10%.
Yeah.
Okay, and the smallest?
Smallest could be maker juice. That stuff over there is supposedly about 5%. There are some vendors that claim 0.5%, but like this resin is supposed to be 0.5%, and I found that this resin, yes, 0.5% dimensional, which is 5% volumetric, which means exactly the same as that, right? So it's difficult to get a clear thing. And then the effective shrink also varies. Your handling will affect it a lot. For instance, ABS, from hot to cold, shrinks 10%. But you don't see these crazy 10% warp parts coming out of these MakerBot FDM printers. Generally, they look pretty good, right? Whether it's the models up front or the Starship over there, right? They don't look horribly 10% warp. And that's because they're being held in position, right, while they're being printed, and that resists shrinking. Similarly, in injection molding, same ABS is going to shrink 10%. That doesn't mean that you take your mold and make it 10% bigger, right? A lot of the processing, the way the stick works, that influences the way that shrinkage works. Shrinkage is a complicated enough issue that Autodesk Inventor, take a mold making class, right? There's a whole software to simulate shrinkage based upon cycle time, pressure, ambient temperature, mold temperature. It's very complicated. So, for instance, this part here, you'll notice from the shrinkage, it's also warped, right? It doesn't sit flat on the table, right? The shrinkage messed up. Same material, this guy, totally flat, right?
Because you printed differently.
Because I printed differently. In this case, I printed also with harder layers, right? 1470 exposure, more than twice as much exposure each time. So the whole thing came out harder, and also it shrank as it was being printed. And so that means that also that the overall shape resists warping. And warping at a macro level has a lot to do with the way that the part is designed. Because if you have a thick part and a thin part join each other, they will warp volumetrically differently, and that'll cause all kinds of strange effects. So there's various design principles when you're designing something for injection molding to try to reduce those effects. 3D printing for this, you're going to have a really big effect whenever you have a big change in surface area between two layers. And that, even in this one, you can still see that there's, you can feel it, you can feel that it comes out, right? The wall is fine, and right here, it comes out, right? And that's because that's where the roof comes out. And so the previous layer is just the wall, and then the next layer is the roof. The change in surface area between those two layers gigantic, right?
So it should shrink more, not less, right?
It's hard to say. I mean, but it creates distortions, right? It'll affect the surface quality of the part. It'll create distortions.
So say I want something that has several parts that need to be matched to each other.
That's extremely hard.
So that's they'll shrink differently, right?
You have to do a test run, determine the shrink, alter your part to take that into account. If you need to have fitting posts, right? There are some mysteries.
What's because of this?
So
They are supposed to be.
it doesn't quite fit, right? They're actually a little bit. These are actually too close together, or these are too far
So they were
apart,
supposed
right? The fit here is it's a bit tight, actually very tight. But this one's a little bit better. But you'll see from the rubbing, right, that the fit is not quite right. There's lots of reasons why this can be. The big one is I printed this at low resolution, which means that small differences in focus will result in large differences in dimension.
So they
When I say
are
large,
designed to be two parts of it.
but they don't fit. They're not quite.
Yeah, I see.
This is one of the things back to the drawing board. There's a number of things back to the drawing board. This part isn't strong enough to go in the injection molding machine. I had another version of this, and I took it back to the Morgan press to inject it, and I did something a little wrong. The press came down and blew the mold apart. And that's partly because between this dip here and the bottom here, you can see through it, right? There's not enough material there. So Morgan press is 10 tons. It's coming down on the injection nozzle, and there's very little material for that 10 tons of force to get distributed across the whole mold, because this area here is way too thin, right? I can see through it in this part. So this is a design flaw. This part here is too thin, it's not strong enough. So I got to make this mold bigger in order to give it more space to distribute the force. Particularly because resin is not super strong. So if you notice that this guy here, and this guy's way heavier, right? And this guy's way heavier because my 3D printed model is hollow. And then I filled it through these holes with, you can see here, aluminum epoxy.
Oh, you filled already?
Yeah, I filled it already, right? And that's why there's all this junk on the outside here, all around the outside.
What's the purpose?
Yeah.
What's the purpose to make it colder or there's something?
The purpose is to make it stronger, and aluminum filled epoxy is commonly used to make prototype injection molds. So for instance, if I wanted to produce an injection mold out in a non-computerized way, I could make a silicone mold of a part and then hand carve the features into the silicone, and then make another silicone mold of the silicone mold pads, and then fill it with epoxy. And in a couple of manual steps, create an injection mold to duplicate an existing part with no computers at all, right? And that's what this aluminum filled epoxy is commonly used for prototypes. What do they sell it this way? Yeah, you're not mixing aluminum powder yourself, whatever. You have no idea. There's a lot of complicated stuff. I bought it from Resin as a compound, and I mix them, and this grade of epoxy, the hardener has chlorine in it. It's quite different than the epoxy you buy from the hardware store. This mold is about 220 milliliters of resin. This resin, I I printed it in is $78 a liter. So I use about a little bit less than a quarter of it, right? And so that means about $18, right? About $18 worth of resin went into, maybe $15 worth of resin went into this mold, plus the cost of the epoxy. No, stuff like that, that's all can be reclaimed. That's not waste. That goes back into a storage bottle. Yeah. Only the stuff that turns hard or is spoiled in some other way. So this is total waste, right? So this is $15 down the tube because I solidify it, right? But the uncured resin, we're not throwing that away. And you shouldn't throw it away. You should never throw away uncured resin. Uncured resin is very bad for the environment. That will all be reclaimed, go back into a bottle, and it can be printed. So unlikely, and it's both good and bad. It would be great if one dead pixel would make a big difference, because that means that my prints would be really, really precise. The reality is that the pixels are not pixels of tiny lasers, right? And this is just light. The light is kind of fuzzy and edgy, right? And so one dead pixel probably won't even result in a hole. You'll see it as a surface defect, kind of like you see these streaks here. But you probably will not even get a hole. The light bleed from the other pixels around it for just one, and probably fill that in. It'll probably be solid. It's relatively easy to see when you just look at it. I mean, I give it like in a laptop display or anything.
So when you talk about that resolution, so is that the actual resolution or the theoretical determined by just dividing the size by the number of pixels? Or that's the real one?
A micron resolution is a theoretical resolution by dividing that size by the size of pixel. And it represents the minimum feature size, right? Because a dead pixel you will see, right? You can tell that there's a dead pixel there. It does become a feature, right? Every missing pixel becomes a feature. That doesn't mean that you have dimensional resolution of 35 microns. You've got 36 or 37 microns. You have 37 micron feature resolution, meaning if I have a 37 micron feature, it will appear in the print, but it won't necessarily be 37 microns tall.
But more than likely, we're talking about a particle that's floating in the air in between the your lensing and your
all kinds of stuff can happen, right? All kinds of stuff can happen.
So the pure you can keep that zone,
right?
The less likely you're going to have those dead pixel zones.
Well, I mean, even just damage and the fact that we're shining through a couple of layers of different material, right, in order to get into it. All of this is going to cause the dimensions of the feature to vary from theoretical feature size. Right? So,
I'm going to give one right now, so not to interrupt.
Sure?
Yeah, we can move on the next.
If you haven't had a tour, I highly recommend it. The shop is cool.
There's one other issue. I know that the projectors, they so we always have these functions.
There are a lot of distortions at all the edges. Especially because of using this home projector. The home projector, like you look at that one, right? It doesn't project symmetrically. It projects like this, right? So the bottom plane, the top edge of the projection is aligned with the bottom of the projector, and the top is way down at the bottom, right? And so this projector has, all projectors have, well, optically they have aspheric optics, right? So even ideally you shouldn't need any keystone, because keystoning affects your resolution, right? The optics themselves are designed to throw a picture that does not have the same focus throughout, right? The focus at the top is different than the focus at the bottom because of the lenses, because the lenses are not fully aspheric, right? And that affects the print, yes. It means that the thickness of lines varies depending on where you are located. And again, that doesn't affect your feature resolution. feature will come out, no matter where you are on the projector. Because otherwise you would, because anything that you would see on the screen would, you would still be able to see it on the screen, it'd be a little bit fuzzier, right? But it would still come out. But the dimensionality of that picture is going to vary depending on where you are on the projector. There's a lot of factors. One factor is an image like this is not uniformly bright across the entire surface. It varies by, this picture here varies probably by 20% between the brightest and the dimmest portion, right? We don't see it clearly looking at this, but resin knows. It makes a difference to the resin. And some projectors use dimming masks. Put a mask to dim down the brightest portions to make the image more uniformly bright. With a tiny one, it doesn't matter as much, because the main reason why you need the picture to be uniformly bright is so that you can minimize the exposure times to save the life of your silicone. Because your silicone has a very, very limited lifespan in a bare silicone vat. With the amount of light exposure it gets. Because we got film on here, the film is virtually immortal. I can always pump the exposure time to the max necessary to fully cure the corners, and don't worry about the fact that my middle is getting 20% or 40% bonus light. That doesn't make a huge difference with this printer. No, Teflon doesn't care. It doesn't react. Where Teflon is not, our Teflon doesn't wear due to any of these chemical photo-initiator properties. Yeah, I'll be here.
Thanks, you're very knowledgeable person about this stuff. I appreciate all your exchange.
Oh yeah, sure. Buy one. I already have one.
But the printer that's, the LCD projector that's in the printer, is that stock or have they modified?
Stock, it's unmodified. And they use this particular projector because it's unmodified. And there are trade-offs because of that. This projector because it has these aspheric optics, this projector is optically not as good as some other projectors for this purpose. In that some other projectors are, from a home theater perspective, crappier projectors, because they don't project as evenly in a case like this, right? You need the projector's optics to be focused differently top to bottom in order to have the wall be in focus everywhere, right? So this is a good projector from a home theater perspective. What we want in this is an ideal printer, is a projector that is not that good from a home theater perspective, that exposes or focuses the corners more evenly, which would mean for home theater use to be really annoying because you have to put that projector in the middle of the room instead of at the ceiling or on a table, right? But a slightly crappier, optically worse for home theater projector would be better for our purposes. But every projector that has those qualities, there is another projector that's used in some other 3D printers made by Vivitech that have better optics for 3D printing. They will not work at all without modification because you cannot get them to focus close enough. You have to modify their lenses in order to get them to focus close enough. And so if you bought a B9 Creator, for instance, right, so pretty much same class of projector, right, class of printer, mechanically quite different. It's mechanically it's a much more complicated printer than this. Because it doesn't have the flexing back. But like a B9 Creator, they modify all of those projectors before they send them out. And the projector we have here is considered to be the best out-of-the-box printer for DLP SLA, but not necessarily the best modifiable projector. But it means that I could print, the day I got it without having to mess around with modification. Modification is not hard. It's not any harder than building your computer. It does carry some risk. That chamber where the lens array is sealed.
Yeah, you don't dust.
Right, so you need to make sure not to get dust in there. When you modify, the spacers in it, you also have to you need to design a gasket to keep it sealed. And so it's a little bit more complicated than just putting a bunch of spacers in. You have to have spacers go on screws. You can buy them in a hardware store, get them from MasterCard, no big deal. The gasket is a more complicated custom piece. Someone on the Kudo3D forum has designed a gasket mold. So it's you print out the gasket mold and you put like whatever kitchen silicone into it, and then you get yourself a gasket of the right size, right? But effort has to go in to actually design that gasket for this particular, or in that case, the Vivitech projector to get it in. I don't know that this projector, if you go down to the 26 micron, requires a gasket. It may not, because going from 37 to 26 is a minor modification. Another thing is the range. This projector can get from 100 to 37 without being modified. If I take the Vivitech, for instance, I don't have that much range. First, I have to modify it, and then I have to choose. I can go 75 to 37, or I can go 100 to about 50 microns. I don't have the full 137 that I get with this projector because the ring doesn't have that many threads. So you have to, it only does whatever 4 turns, you only have that much distance. So I can space it up or down, but I only have that much control.
Now, if I'm going between 37 and 50 microns, and I know from talking to John that you already had the projector set at the correct distance.
Yeah.
Now, the focus of the projector, do you have to adjust that focus, or once it is set, it's set? Because I've seen your competitor, you have to focus on the build tray and then targets to try to focus to.
Well, there's a calibration grid. You calibrate, the calibration grid is focused against the build plate.
Right.
The build plate is set at the level of the vat.
Right.
And you focus against that. In theory, the vat floor distance is not the same between different vats, because almost all vats are it's flexible, but also they're hand poured. And so they might not be
You're
exactly
talking about hand poured, like the B9 one. That's a film. So is there any board on that?
Yeah, there is. There's silicone underneath it.
Oh.
In order to enhance the release, there's silicone under the film, so that the floor is not so rigid, so that it will move.
Could you explain to me then what the layers of the build vat are then? Because I thought this is just a
I'll tell you the ones that I know of, but there's actually, Ted has said that there's a secret blend of 11 layers in here.
I won't.
And I don't know what they are. From a user perspective, there's the acrylic floor, then there's a layer of silicone, and there's the film on top.
Got it.
Right. When you look at the film clearly has multiple layers in it. Right? You can see between there and there. So this is actually not just one film. This film itself has a couple of layers. The silicone, to my knowledge, doesn't have anything underneath it from the vats that I'm using.
Now, with something like the B9, I would have to pour my own slide guard, or however it's pronounced. What do I do with this printer? Am I just buying new vats, or am I doing any maintenance?
You should always buy new vats. The vats are $59. I have filled vats before, because when I first started printing these guys, I print flat against the build plate. They stick like crazy, and I had a lot of trouble getting these to work without warping. And so I printed them on bare silicone. But printing a flat object in bare silicone, you get one use. And so I have removed the film, printed on bare silicone, removed the silicone, re-pour it. It's a pain in the butt. And the only reason why I ever do it is because when I print parts on bare silicone, they often consume the silicone after just one go. It's too expensive for me to buy a new vat after just one print. Unless you're doing something off-label like that, the film will last easily over 100 prints. And at $59, there's like no reason to bother messing around with trying to even relay down another piece of film.
How is their vat supply? Like, could I order a second vat when I get the printer, or are they back ordered? Because I know.
you can order as many vats as you want. They're not back ordered so long as you can get your hand on a printer. There is a lead time in shipping because the V2 vats are warehoused in Taiwan. So I ordered 2 V2 vats, and it took 4 weeks for them to get here. But you should not have problems getting more back. The vats are really, unless you make a mistake or unless you, I mean, I've gone through a lot of that because I deliberately disassembled them and used them for off-label uses. Unless you're deliberately messing around with the vats are nearly immortal.
Well, I just changed the subject since I have your beer. We talked about very little difference between 25 micron and 37 micron.
That's what I've heard.
That's what you've heard.
Ted has actually done it before. I've never printed myself less than 75.
That I would think would be a good advertising thing and able to show that. Because I do look at people who are printing in the B9, but it's not that often you see them go down to the very lowest
You
level.
rarely need to for jewelry, for other things. It's rarely necessary. And it just, you know, I mean, it's also, I guess, a different non-usage. I bought this printer because I had big parts. So this is the only printer that can print a part of this size. And the B9, I had to print this part like this on the B9. And it turns out that, I mean, I had a lot of trouble finally getting a part like this to come out when I was learning to use the printer. I once tried printing it this way because I thought that would minimize the surface area. It creates a boatload of additional weird problems. Yeah, go ahead. Oh, you're wearing gloves even, so yeah, you feel free to handle a broken one. Because the inside is a bit soft. It's not fully cured on the inside.
That's what these are parts for using for making molds.
This is an injection mold. So this is an injection mold specific to use here at TechShop. So the injection molding, the Morgan press here at TechShop has a little divot on the bottom, and that's what this is for. And then at the top, we have a screw bushing, and then there's the screw bushing is a aluminum piece that goes in here. Screw bushing has a little circular top, and the injection molding machine has an injection nozzle.
You're telling me that resin that you're using is strong enough in order to do injection molding with this as the mold?
In theory, yes, if it's properly designed. This has a terrible design flaw in the not. You will notice that the injection molded nozzle, where the 10 tons of force comes down here.
Yes.
Right? And you'll notice that that is the thinnest part.
Yes.
Right? So this has a terrible design flaw. This does not withstand injection molding.
Now, could you?
But I will thicken it, and then it should work.
Have you considered, instead of using that directly as the mold, casting from that and then using another material, with a different material such as a resin?
I could try to instead 3D print another mold to make it from. I considered that from before I had this printer. I have an FDM printer, and so I was thinking, yes, of printing out ABS molds of molds and then casting them in epoxy with the strongest stuff.
Because I was thinking you could use silicone to create a mold of that mold and then cast it in epoxy.
I could. I mean, I'm not super good with silicone and manually putting in parting lines. So I would probably, if I were to go the mold route, I would take the mold back into Autodesk Inventor and have it generate me a mold for this mold, and then 3D print that. I have an earlier prototype of this. Actually, I 3D printed and cast in polyurethane, and so that was, and that worked out fine. That was how I tested to see whether or not the mold design would even be in the ballpark of being injection moldable. So I printed out a version that was designed a little bit different designs, designed to be filled from the top with polyurethane to validate that I could actually produce parts.
Do I understand this more correctly in that the plastic goes through the top of
Yeah.
There?
Yeah.
I'm sorry, but why isn't that end cap then? This?
Oh, because this is a hollow part. There's a third piece missing. This is supposed to be a diffuser. And so it's going to screw onto the end of a flashlight, and the inside is hollow. It's not solid.
Okay, so
So
there's
there's an
physical-
aluminum bar, aluminum insert that goes in here, that's held in position by this neck here, and it floats in the middle, and that produces a 1 millimeter thick piece. I didn't bring that part because I wasn't demoing, but yes, there's a couple of things. This hasn't been drilled all the way through because this part is scrap, and so I have to drill this through, and then yes, and then there'll be the aluminum. There's an aluminum insert that goes in this way, and then there's another bracket that holds the aluminum in, so when I inject, it doesn't blow the pin out.
So how many times would you put the injection mold into that thing before?
I don't know. So a polyjet is really the best thing to make these resin molds out, not sterile lithography. Because it's a challenge to make a mold like this in sterile lithography because of all the separation forces. Because this came out pretty well, these two guys are pretty flat. But getting perfectly gigantic flat objects is hard. I mean, I won't lie to you. It is difficult to get these large flat objects out of sterile lithography because you have all this separation action, right? The way that prototype resin injection molds are usually made if you're making 3D printers with a polyjet, which is like those inkjet printers, same type of resin, but then an inkjet head and then UV light on the outside that shines onto the surface, and then it draws like an inkjet printer.
Are we talking about an objet?
Yeah, like an object. And this is one of their, and these polyjet type printers are often used for this purpose, and they use ABS-like material, and some people have said you could get up to like 10 to 40 shots out of it. Which is nothing in comparison to aluminum or steel. I don't really know.
What would epoxy do? Because I've never done injection molding. Would it be worth the extra step to convert that to epoxy?
I don't know. I mean, I'm certainly using epoxy on the inside of it. But to be honest, I don't know. I haven't had a successful shot yet. The first working mold I had, I crushed in the press when I went to try it, and then this has distortion problems. It doesn't fit properly, and so I have to go. And then it has a design failure, so I have to design flaw, so I have to go and fix that up. So I've got a couple of things I have to fix up before I have another go at it.
Everything
Probably, yeah. That's what it's really made for. It helps conduct the heat. You're not so worried that it's not tough enough. You're worried that it will soften because of the heat of the plastic. The plastic coming out like 350 degrees. 350 degrees is enough to warp even this thermoplastic, but because you have a big mass, it's not going to make, and I'm only injecting a very, very small amount of plastic compared to the overall mass. I want the heat to kind of dissipate across the polypropylene. You could inject ABS too. ABS you inject hotter.
When I took this quarter to the 37,
I got to go back.
we had an advanced manufacturing course at our but I mean, just using it with really good experience. I don't know where you can get access to one they have, they connect you to there's a chance you might go like and actually go as part of
That's the problem.
Oh, I see.
If you go all the way,
I mean, that's the best way is to
It's supposed to be like this big at full scale, or however big you want it, and then just shrink it down. And then once you get that, it's bigger. And
The rest
it's not really that complicated.
it's not just exposed model. What can you do for the rest now? Is that partially exposed? Can you pour it back?
That project,
Pour it back in. Here's a good idea to shrink.
just when you make mistakes, it's just gonna add up costs. Yeah.
I think I will bring it down, the work it down to the pieces, which because the customers are based or the work. So the rest of the pieces that I handle, you are best practices. Yeah, how they break down, let's break it down.
You can take one if you want. I'm just checking it out. They don't really cool.
Yeah,
I mean, they don't work. Oh, man.
Calibration is off. They don't work. I mean, you can look and see how they work.
Yeah.
If I had design right, there's some focus issues when I printed these out last night. Let me take one and fix that. So I didn't have.
What juice is that in?
So if I was printing with the 37 micron, 37 micron,
So
I guess
you have
37 micron, the XY resolution.
XY resolution.
What would be the minimum wall that I could print?
I don't know. It would depend on resin.
So, I mean.
I've been asked this question before in reverse, because some people want to use these printers to do microfluidics. And so you want to know what is the minimum channel that you could get in a block in order to produce microfluidic chips. I don't know.
I know, well, or, so if you made a smaller, if you make like a smaller scale, you could do like 16th of an inch one, to start, and that would probably save you a lot of time and money. I mean, it'd probably be good, just at least do like the smaller scale for one layer of it, to get that one layer down, and you understand how you're gonna build it for the rest of the layers, and then maybe you want more than you now.
It was interesting.
So you don't need to, maybe you don't need to build the entire thing at a small scale, but
Your
build
competitor are not going in.
like, so if use all of the methods of the manufacturing that you're gonna build it with, so you have like laser printing, 3D printing, and how you combine them together.
Without
And
having to
figure that all
model,
out.
yeah.
Then once you have that all figured out,
For the 25.
essentially just doing the same thing every month, right?
No, does it have
So
to be a
once you figure that out, then you can
add
scale
some
up to
sort
the
of
big ones. And
I tried the lens thing because I don't want to modify it.
Yeah.
They sell them. They're
You
horrible.
definitely need a laser.
The biggest problem is that
And
they interact.
they
We
don't.
talked about earlier how this lens here is
San
asymmetric,
Francisco one
right?
has.
In order to focus the bottom and the top, even though the distance from the projector, right, is way bigger at the bottom than at the top, right? And so this lens is not symmetric.
You definitely
And
can
when
build
you
it.
put like a magnifying glass lens or something on that, it interacts
You still need a
between.
3D printer outside.
So you can get it down, focus it down,
That can build.
but you have like your lines are not straight, there's weird curvatures, it's weird.
For what you want.
If I'd known you were gonna get all these questions, I would have bought it, but I bought
Yeah, so do you recommend?
not the Meecraft, the Move 3D.
Definitely not.
They also have a
So,
DLP 3D.
The filament will work for
They
yours
sell,
because
lenses
yours, that like the spiral
for
staircase,
that. I
that's
bought
really hard.
But they're
Even if you
useless.
print it, so FDM is bad at really fine details.
Well, they're not
FDM is the filament.
for a set of
So the filament 3D printer is
They're
bad at
not,
small,
they're
fine
cheap,
details.
but
This one's really
they're
good at that.
useless.
And it's also bad at kind of.
Well, I mean,
So that is like a lot of unsupported areas.
Screw them
So
all
on
like a camera.
the
It's not
filament, you will
really a
just
big
kind of
deal,
like.
they seem to work okay.
And then, so this will give you a
But,
better.
but on this, partly because
You want
you
to.
can't control the distance between
It's
the
not gonna look
lens,
good.
that lens,
What's
and
the-
the
You might as well
lens
just
here
show the
precise,
CAD
you're just
model
sitting it
rather
on
than
top,
build it.
right?
Build it, you
So
want
it's
to-
hard to get it aligned,
It's like, that's definitely.
close enough, right? It's just, they're not, you probably need to get that lens behind whichever stage is sphere.
You need
If you did it way earlier in the chain, in the laser phase, it might have some effect, but it does not. It's not an alternative modification, unfortunately. I would have said a lot of trouble, like, fuck my on, wait, fine, pull it off, no, 50, but no.
Color, or you can just
It's not that good.
paint it all in the same and paint them. Is that, I mean, that'll probably.
I was very.
So
There's no shortcut to the lens.
I should buy
That I know of.
mine.
I think you should. Test it out with all fives.
That's
So that's what, so
I
like,
did not know that. The other thing is.
there's a chance that if you went pretty
Even though
close and found, like, there's people that have these type of prints, you could ask them,
you go in
print
the forums, you
this,
look at what
this thing,
resolutions are actually.
probably cost like $75
$75.
It's my goodness.
Yeah,
Oh, no.
and so then
They're
you also
not-
need to ask them,
Well, they're higher.
kind of explain it to you.
What it is, people are, they don't.
I have one similar to this, but shadier.
But.
No, higher resolution.
How much would you charge to be 30%?
Yeah, the 30 will be faster. The lower because the higher, because the light intensity is great.
I don't
The
know.
smaller the area you're focusing on, the higher.
I mean, I'd be willing to
Um,
try it.
So smaller areas will be
I
faster.
mean, try to figure it out.
But then, I mean,
But,
no, that.
Would you like to try fixing something?
Big market is 30. 30%.
I'm kind of busy right now, because right now, I'm kind of busy. And I'm trying to get my fully functioning regular ones.
Talking to guys from that podcast.
Do you think?
I didn't want to see this because I guess one of the two.
I have no idea. I prefer architecture based things, I don't know.
Oh, I see.
They like.
But I mean, for just 3D,
I remember when you had your Kickstarter.
There's a lot of.
So it's just, it's an action on one end.
So it would be nice if there was like a place that had
Travels that way.
a bunch of.
There.
You can go and try it out and learn on it, right?
Yeah, so.
Instead of buying one, so.
So big flat guy like this, pretty flat,
For
gets
example,
the
if I
bed,
buy this
like
thing,
7 millimeters.
teach me
How did it know?
That's a good
How much
question.
is that something about
That-
adjustments?
Trial and error. You just,
Probably a lot of
just
videos
software,
online.
come here,
Ah,
take a look.
Yeah.
Alright.
But I don't know. Yeah.
What's your?
You basically program it, code it, enter in is basically for a given set of
Like,
layers. When the exposure time lift.
kind of do
up
later,
and
or
down.
see what's happening
And
with your project?
especially for the flex
Information that I deal with.
lift and speed.
Yeah, I am on website.
Like 5800 is extremely impressive by most standards. Just this is a low surface area part, so you'd be fine. 100 millimeters a second lift.
Are you working currently?
No, actually, I
That wouldn't survive. I had
studied
to get that different. I was doing like 7 millimeter lifts, 10 millimeters, real slow,
And then I.
in order to get that. Get that off.
It has to break that seal.
Yeah, it's gotta get all the way across. So especially because that last edge, right, just holding on the edge, the big flex, you also raise it a bit more just to.
Now, I noticed
Any
all the
kind
things you talked about here, it looks like everything is just straight up or down.
I try to research.
They have people on the forum experimenting with printing at different angles.
Always start with printing.
Well, I mean, that.
For SLA,
Incredibly
always
useful.
print angle.
Oh, yeah.
That's standard. So
Yeah.
this represents, like 100 hours of
As I said,
experimentation
it's
before I
very-
got to
it's
this.
very difficult.
I have all kinds of
But
prototypes where
If you
This.
wanted to learn how to
this,
do all these things,
right?
that's like a
Um,
perfect project
and-
to learn, because there's so many things involved in that.
Yeah,
It's a very good project to learn.
You
Well,
can
I
print
made
flat
another one, it's something like.
with this printing. Unlike anything with a silicone,
Just there like this.
where you really cannot print
It's not
flat
very
because you would consume
Really nice,
silicone.
oh my
and
god,
print.
oh my god.
You can print flat, but I would never advise anybody to do so.
You can.
Because-
Go to my website and there's also some.
There's-
I love the project. And also the.
Well, it really has to do with the learning curve.
The quality center,
When you print flat and it doesn't work, you're left with basically nothing. It just doesn't work. No idea why. When you print diagonal, your yield is much better. But flaws are much more likely. Big flaw is that warping is way worse when I printed it sideways because the force holding the thing flat was much weaker. Right? Here, when I print like this, there's a massive force here holding this thing flat. Right? I mean, it was really hard to get this off the build. That was a good sign because there was a huge amount of adhesion holding this thing flat. Printing sideways, the yield is better. Almost every prototype came out, but they all kind of weird flaws. But it's easier when you're learning to start with a flawed part and then tune it until it works than to have nothing. And then you have to like, what is wrong with this? I got nothing. I have only scraps in the bed, or it only prints to here and then nothing. It sticks to the build plate. I have nothing to go off. And so printing flat is a challenge. It's a challenge because when you're diagnosing the print and it doesn't work, you have way fewer clues to go off of. So you need to pretty much know all the variables before you do something like this. This is hard.
I'm just wondering if something like this. Now, obviously, you'd have to have supports here.
No, I don't think this.
You don't think so? Because of this. But the thing that I notice here, my guess is this is what, 100 micron?
Yeah, and this was printed flat like this. You can see from the this was printed. This was not printed at an angle.
Okay.
This was printed down like
this.
This is possible because this part, by nature, is all angled, right? This part, when printed in this orientation, doesn't have any vertical surfaces, so it's no problem, right? It's not an issue of orientation part, just how much vertical surface, how many vertical and horizontal surfaces do I have? Printed like this, I have very few to no vertical and horizontal surfaces. That there probably was support. There had to be support to chin. Well, more than that, because this chin is concave, and so it floats out in the middle of in midair over here. So there would need to be
because if you end up creating an island with resin float.
Yeah, it would float in the middle of nowhere. It wouldn't adhere to the rest. Everything has to be attached. And yeah, you can see there's support here. The nose, for instance, this guy probably did not need any support. Maybe one tick here, but very little.
Probably relatively low res. Now, was this to a 3D scan or?
Oh, in terms of the detail,
yeah.
I don't know how. I mean, it probably was. I don't know about. This looks like it was based off of something real. The low res, because yeah, it was printed. The size, this had to be printed at.
I would assume that you would have had a higher res output on that because you look at the smaller pieces.
Yeah, you'd have to print this at 100 micron on XY
to get that build
in order to get this build out.
Okay, so if I wanted to drop that to 50, I would have to reduce that by 50%.
Yeah, or you have to cut this into parts somehow.
The reason I ask about that is when I look at something like you go down the Monster-Palooza where people are making their own busts and whatever they're sculpting. They're not that big and they're casting resin. So if you get it this size, 50 microns, that would be interested to see what the detail is, see if it can hold wrinkles, see if it can hold pores, see if it can, how much detail it can hold compared to the Form 1, which is what a lot of people are getting.
Well, the Form 1 is different.
Yeah, it's a laser. It's not going to have the same XY res because of the spot.
Yeah, but it's a laser. And so by nature of it being a laser, the edges are way more defined. So there's a trade-off. Lasers are, from a light perspective, magic. There's no comparison between a laser and like a pixel like this. Laser is a collimated beam. It has a defined edge, and that edge is very, very sharp compared to the edges that we have here. So it's quite different than what we get out of DLP. In the end, DLP will give you better features because you do have the smaller pixel size, but you have some different properties on the edges.
Well, the thing is, that's the price point effectively of what this is. And for people printing in the approximate same size, like I've been to Maker Faire and I've seen the skulls and the busts that have come out of that. That's where you want to show the difference between the two.
Yeah, it's difficult to say, right? Because the Form 1 uses a motorized galvo system, right? So there's a motor that moves and sweeps the laser. And that means that, let's say I draw a diagonal line, right? There's going to be a big difference between the way the diagonal line looks sweeping a laser, even if it's a thicker laser, on a diagonal line compared to interpolating with pixels.
Yep.
And that will affect all of the surfaces.
Well, the trade-off being also is if you read the Form 1 forums, they've had a number of return problems.
Well, they have Galvo focus issues because their Galvo is a black box. Nobody knows where they come from, and they're quality control problems. I've seen a lot of complaints about that. And some of them is also that it's difficult to tell what a problem with the printer is when it's not working. So it might be a Galvo problem. That's what people are afraid of, but a lot of times there are other problems with the printer, simpler problems that are the real root cause. But it's the technology there is very different. There's different strengths and weaknesses. Some of the problems I think with dimensionality on edges would be quite different between a laser-based system and a DLP
if I
system.
were to buy again, I'd probably go yours instead of that one. I was
The thing
also,
I'm taking away
my boss
from
at work wants to buy one,
this
so I was trying to decide what
is, it's very interesting that you said I was able to print with this out of the box.
with
Because
different.
you don't necessarily read that before it's for other printers.
You don't necessarily read them from yeah, I don't know if you've been reading before. You should read them from the very beginning, right?
That's some start.
Everybody has problems. There's a lot of the problem is fundamental to the way that a DLP-based printer works, which is this is the laptop second projector, right? And so the biggest class of problems for people who start out is bizarro Windows problems because of the way that different video cards.
Yeah, I know what it's like to set up a projector for a presentation.
And so this is a big issue, especially if you don't have a dedicated printing.
Right.
So you bring the computer, you take it back home from work, you plug it in, you hit print, and something really strange happens. There's a lot of issues with
the first one attaches.
And so a lot of people have problems with this. I didn't because part of my setup for this is I bought a dedicated computer. I bought a Windows laptop for
Because you probably
printer
get
170.
Yeah, oh, okay. Yeah, you get something.
Well, because
for
my
$300.
experience is that, especially with Windows-based control, is that you really need dedicated hardware for 3D printing because this thing here is really CNC control. So you can't be using this CNC controller to doing anything other than controlling your mechanics. That's not just my experience. Like the Tormach here, that box is reflashed every time you restart. It reverts to its original state. So it's got to be that way because you cannot afford weird driver issues or anything when you're controlling the linear state from the computer. Doubly so with this second hardware business. So that's a challenge. Another problem is there's a big learning curve between going to printing out of the box, where all the settings of the model are given to you, and then going to your model. Right? The intuition as to how to orient a part and where to put support is difficult. I mean, take shit out by doing that. There's no orientation involved in picking the orientation for a part like this.
Oh, yeah, you just like, yeah, I know that was kind of a but it's a very impressive.
If you were able to do different.
Because the part has a very, very small surface area, per layer surface, max surface area, individual layer, just a couple of dots.
I was very well.
Your supports are very flexible. A lot of them support without having built.
Essentially raise the build platform.
A lot of people, when they start out,
And
we bring it with attachment.
Resin, bring it back down, so that
have,
it's surviving that. But if you don't do that,
interlayer separation
when you hit print, doesn't.
you'll have
And
problems.
so I was just doing it, initially I was doing it as a dry run, like I'll.
That's over bits
I didn't need to write
floating
lower
with that,
but
because you just put support, right, and
Right.
you don't
Really
know,
know
be really
why.
sensitive to seeing mysterious pieces of here out of nowhere.
So what
All of these things are things which
So in the exposure time.
software could detect,
You overexpose.
but today's software does not.
Overexpose.
And more than that,
Build layers, right? Is that just
it's
damage?
non-trivial programming.
Like it doesn't.
FDM printers, open source software is not very advanced in advanced tool architectures. And for SLA, we're not nearly that advanced. We have no notion of, oh, what if my focus is not perfect in DLP? And so I need to compensate by pulling my edges in. Because I have a problem where I can't scale, because I've got holes that wouldn't be too small. Or in negatives, I have to make sure my negative space and positive space are both properly compensated. And we have no tool that will compensate for that. And we'll look at this and dial it and say, no, my focus is off. My focus is off by about 0.2 millimeters. So anything that I'm projecting 1 pixel, it's going to be 0.2 millimeters off the side. So let's bring my edges in by that much amount. There's no such tool that will do that. There's a lot of things that our tooling could detect that it doesn't, because it's somewhat complicated.
It's pretty.
What I see when I go on the forums and I go into software forums, so I'm usually on the ZBrush forum, or I'll get on the Meetup forum. And people are interested in making these. They have these ideas. I'm going to be a toy designer. I'm going to make figures. I'm going to make jewelry. And so the tolerances aren't necessarily the same here. I mean, when you're talking about negative space, yes. I mean, you have to be able to print a ring and have close to the ring size. Because there's also going to be casting issues when you're going to have metal shrinkage when you do lost wax casting.
But I mean, imagine you're making a figure, then you've got a ball and socket, right? You've got something with a ball and socket. That's got to fit. More importantly than that, this resin is not a good fit. Any resin is not a good fit for a sterile fiber resin. It's not a good fit for these rare parts. Even the strongest resin that you can buy today that I know of that makes solid bore is brittle. 3D material stuff is brittle. And so when people use this, when professionals use these prototypes, and they have snap fit parts, they prototype and print it so that the snap will work once or twice to determine that's going to work, and we're good. And then we're going to go make it in ABS. They know that that's a property. You can never produce a production part.
No, what I'm looking at is people who want to do something like a low run of action figures or toys, or be able to do an assignment in college. So they're going to be printing the prototype parts and then casting them in silicone.
Well, I think
and then casting them
there's a
in
guy
resin.
in Oakland that John and Ted who's actually doing production t-shirt. The same one how he runs his tight one like 20 hours a
You have the
day.
guy's name?
John, I only know his first name, Josh.
Yeah, no, Josh, with zombies.
No, so they do game miniatures.
Exactly.
Josh, zombies. I want to just send an email, also do a breakdown of
Yeah, there's many, not for me, but there's many places. There's a site called 3D Hubs, and 3D Hubs is kind of a peer-to-peer. You have a part, and then some dude will print the part for you on their 3D printer. There's Fictive. Fictive has a relationship with TechShop here, so you can probably find posters here. And basically, they have TechShop here and Menlo Park. They have a Kudo3D systems printer, and
then you're arguing,
and you can through Fictive get a part quote, and then they'll print it here, and then and then you come to TechShop and pick it up.
But you don't.
More likely to get out of the box.
I don't do anything.
Oh,
I don't.
wait. So I understand that you.
Advertising points.
No, I don't work.
Oh, you don't?
I'm just a user.
Oh, you're just a user?
Yeah, I'm just a user.
Oh.
Yeah.
Yeah.
So I'm making my own stuff, right?
Oh.
I'm not. I don't work for.
So if you want to like learn to use this printer, where would you, I mean, is there anywhere that you can be like, before I spend an excessive amount of money?
Go to YouTube. I have a ton of YouTube videos, hours and hours of them going through how I clean my vats with soap and water, and how I print, and how I debug prints and stuff. So if you want to learn about it, you can go there, ask questions on the forums, right? There's a variety of other people who come here.
Well,
You've got the world's experts on this printer.
Shrinkage has more YouTube hours than
You have to be careful too with
But
so if you're using.
But so there is like those 3D hubs you said it's peer-to-peer, right?
Yeah.
And fictive is.
Fictive is a pro thing. So fictive is
Network, right?
yeah, they have a network of pro shops, including TechShop.
Oh, including TechShop.
Yeah, so TechShop has a printer here.
Yeah, but that's not this kind of picture, right?
It's way better than this one. There is a 3D Systems printer. One of these tens of thousands of dollars of printers. There's one here and there's one in Menlo Park. Members cannot use them. If you're a member here, you've never seen this. Go back and see this. I saw one here. Yeah.
So how
You can't use
shop?
it. Members cannot use it. You go to Fictive, you upload the part, you get a quote, you pay for it. They'll print it for you here and you drive down here and get it.
Okay.
It's very similar to these online places like Sculpteo and Shapeways. Yeah, so Sculpteo and Shapeways, basically you send the part, the automated system tells you how much it costs, and then they'll 3D print it and mail it to you.
Okay, but then if you design it and you take into account for this.
Shrinkage is much less of an issue. These variations and dimensions are much less of an issue. When I buy my hobby software, hobby stuff, right? One of the things I like about the Form 1 is that it's an open resin system, which means I can use whatever resin I want. This one. But in Form 1, you can still use third-party. There's no stopping you. You have enough control in the Form 1 software to use any resin you want. Right? In a pro printer, like a 3D Systems or an object, right, you always have to use the vendor's resin. And the vendor's resin is at least triple the cost of any of these resins. It's been specially made for that printer. And so a lot of these variables, when we talk about shrinkage and other things, they don't apply to the high-end printers.
Okay, so you guys send
they
them the
control everything, right? They control the laser, they control the mechanics, they control the chemistry. The chemistry is matched to the laser, or matched to the optics, and so all of that is integrated.
I'm gonna send you an email. Have you heard of anyone like essentially hacking
Right now,
the Stratasys machine to use open source slicers?
I doubt they'd be using to.
Also, like there's for extrusion, there's a slicer that prints it in 3 dimensions instead of printing in layers to create like a lattice structure.
Oh, but that's for FDM.
Yeah.
I don't think that you would want that in a Stratasys printer, even in their FDM printers, because those printers are climate controlled, and so everything about the slicing algorithm is closely tied to the material properties that they can control for, because the inside of those printers is climate controlled. With a maker binding open things, there's a limit to how good you can print, because you don't have control over the climate, and you don't have a match between the printing temperature and the material, right? Because we have many different materials you buy from different places. They have different material properties. Their curves of how soft they are at different temperature varies. And of course, I don't have temperature control. The Stratasys material is, for FDM even, right, is designed to be run at a specific temperature, a specific way inside of that climate control build, so that you get extremely repeatable results. And those parts, their ABS does not shrink. None of this 10% shrinkage, whatever. That stuff doesn't shrink. It's wicked expensive, right? But what you have is compared to all the variables that we have here, many of these variables have been eliminated in the high-end printers, right? That's in reality what you're getting with the $20,000 to
So what
hundreds
are-
of thousands of dollars printer.
What are those other places, sites you were setting up?
The easiest one is Sculpteo and Shapeways. SCULPTEO. EO. They're based in France.
Oh.
They have very, very competitive shipping rates to the US.
And the second one?
Shapeways. And I've never used Shapeways before. I priced out a part that I needed really fast on Sculpteo and in Shapeways. And it was cheaper and faster to have it done at Sculpteo. They got it to me.
Is there any particular forum that you would recommend to ask questions?
Depends on what you want to do. If you're interested in building your SLA and integrating stuff,
A forum where you go?
then
Where I can?
well, buildyourownSLA.com.
What's that?
BuildyourownSLA.com. That is the support forum for Creation Workshop, the slicer software that Ted showed. And that's a community of pretty much self-integrators. Most SLA printers use their own proprietary. Build your own SLA.com. Yeah. Build your own. Use their own slicers. Even this printer could use its own slicer. It has a lot of unique feature properties that affect the way that you design or lay out a part. You remember that this thing flexed, right? And it's held fixed on this end and it flexes this end. This means that the stress on the part is not uniform across the entire x-axis. There's more stress here because this side doesn't move. At the same time, there's more overall deformation on this side, right? And so there is a big difference between these two. This side is more prone to parts breaking off. Features on this end are more prone to getting a bow in them. They keep that. Well, this is a small build plate. The small build plate sits pretty much in the middle. The small build plate is designed to fit in the best part of the projection. So it's the most in focus part and also the most even projector, which is pretty much right around here against the top. It's not the dead center. It's around here in the top, and that's where that small build plate goes. I generally use a large build plate, about this big here. And so a dedicated slicer would take all of that into account when you lay out parts. So this is all stuff that you would need to know. You need to learn from using the printer and seeing what comes out.
So the question I had was,
thank you.
So I bought DLP projector and essentially my first layer's cured and then the next ones didn't. Well, they did and then they didn't stick. What's the negative of overcuring just to get to work almost? It
depends on the type of vat you have.
Okay.
If you have a vat like this that uses where the surface is a Teflon film, there's no downside. Just pump up the exposure. If you are printing on bare silicone, then you consume the vat faster. Any extra exposure that you don't need will cause the silicone to cloud faster. I mean, that's a chemical reaction.
Can you buy those?
What, these vats? Yeah, you can buy them from your site. I mean, they're designed to be held on a specific way. You're going to have a hard time holding this onto, right, something that doesn't use a flex lifting system because you only hold on this side.
Yeah. I mean, I guess I just spent.
To be honest, I mean, if you remember here, you can make this vat not very hard. I mean, you can get a piece of scrap acrylic for a couple of bucks from Tap Plastics, and you cut out the sides in laser cutter. Cut the film out with scissors. Out of like milk jugs or something. You need something flexible. For Maker Juice, you're not too worried. It's almost anything, right?
Like adhesive between them.
Yeah, the adhesive is just silicone. Just 100% marine grade silicone. And then if you're making it for your own printer, right? Just whatever. You don't even need the flexing. You don't need the flexing and force soluble acrylic and then use use the acrylic welding stuff. They sell it at Tab. If you want to make your own bags for your own stick,
And then so you can do the Teflon on top.
Teflon on top. There's a reason why other printers don't use Teflon on top. The reason you don't use Teflon on top is Teflon on top is stickier than bare silicone by like triple, right? And because we have this flexing system, we gain a benefit from this flexing system rather than pulling straight off as Form 1 does. And it nets out to be that we have a printable amount of release. So it's not too sticky, we can still print on it. And we get to use silicone, which is tougher, right? But if we're using sweeper, that wouldn't work. And if you're pulling straight off, that would be also difficult. And so if you want to print on bare print on Teflon, roughly speaking, there's only two ways to get that to work. You need a flex release system, and you either do it the way that Kudo3D did, which is their patented way of doing it, or you build a tension flex vat. There are lots of designs for these. You go to builderonSLA.com. They're kind of complicated because it basically means you have just a film and you hold it in this brace that tensions it, so it's like a drum, right? And that then you get less total flex, but flex in many dimensions as you pull off. And people say that works, I tried to design my own flex vat, printing on PLA. It's hard. Designing that is difficult. The tensioning system is very difficult. You need to hold the film under a lot of tension because it's got to be flat. If it sags, you have all kinds of problems with the layers not being even.
Yeah. Okay. So if the Teflon ever separates from the silicone, and it kind of like either has a gap or liquid in between, does that just completely ruin?
It depends. In the V1 vat, you will have to use some kind of transfer adhesive or transfer tape if you want to stick or flake the down, because this vat is very hard. And I believe that this film was set while the silicone was still soft, floats on top, and it really held in place. In the V2 vat, the silicone is much softer. It has better release properties. It also means that you can probably re-adhere new silicone and new Teflon back down onto it more easily. Also prevents the Teflon from pulling up. And the reality is that the vat is $60. And a V2 vat should last well over 100 prints. By the time I've reached 100 prints, I would just as soon buy another vat. It's the only case where I want to refurbish vats when I'm doing stuff where I only have one print out of it. Some hard to print parts, I'll print on bare silicone. And then if I print them with straight walls like this, that silicone will last once. And okay, I don't want to buy a whole vat, just use once. So I'll go through the effort of pouring the floor and stuff and refurbish it myself. But for anything that I get like, 100 or more prints on, I wouldn't bother fixing it up. Other things will probably go wrong by then. I mean, like this thing, over the long term, probably this acrylic will get a bone from all the lifting. I don't know for sure I can figure that much out.
That's why I was somewhat surprised there wasn't like essentially the same lip on the opposite side, that once it comes up like 2 millimeters, it like knocks it
I
off.
thought about building something like that with a bar and a spring.
So like holds it down to this.
Because these two holes are right there.
Yeah.
I haven't needed to. I've thought about it, but it's a bunch of work. It's possible. I mean, it would make lifting foolproof in some ways, and that there would be a fixed maximum. Whatever that distance was, you go another ½ millimeter above that, you're releasing, right? It might break your part, but you're releasing, right? If you go above the stop. But I haven't, I don't know that it would make such a big difference. Because I've only had really crazy lift and sticking happen on bare silicone. I say that the Teflon film is stickier than bare silicone, but there's a max limit, and then it'll release. With bare silicone, if you really overexpose it, then the silicone will become chemically fused to the part, and then you just keep going until the silicone tears off, tears a chunk of it off. And that level of stickiness will never happen with the Teflon. Teflon's minimum stickiness is higher than the minimum stickiness of silicone, but there's a max limit. So you're never going to get any kind of chemical reaction.
They made it, you have to manually post that protector, right?
Yes.
Okay. Is that just with like a sheet of paper and looking at it?
I would use the build plate, lower the build plate down to 0, and then I shine it against build plate, I set it, and we'll stick this foam nub in there, and I hold it in place, and that's it.
Okay.
I've done that like 3 times now.
So when they were, I don't know if that was actually said or if I imagined it in the presentation, but so like if you're doing a really small part, you're only using part of the projection area, like the projection area is this big, but you're only making part of that small. If you actually brought the projector closer, it would increase the intensity, like essentially make the projection area smaller. Is that actually possible? Or?
Yeah, I mean, this thing is on a bracket. This bracket is designed to be moved, right? So the thing is that the calibration sizing changes whenever you move this thing, right? So there's a procedure every time you want to change your resolution, and that's what you're really doing. When you're moving it closer, you are increasing the resolution, right? In that, you get smaller and smaller dots, and that also increases the intensity. And then you further away, bigger dots, less intensity, longer exposures. But whenever you do that, you need to recalibrate. First, you need to recalibrate the levelness. It's got to be level, and so all the tilt, you've got to make sure that you get that right. And then the dimensional calibrations, the slicer, how big is the pixel? You have to do that again. Depending on what you're doing, it's super hard. I find it kind of annoying. I don't move mine a lot.
Okay. And is this yours?
What?
You own them?
I have one.
Okay.
This isn't mine.
How about you? And have you used the Form 1s and the other ones?
No, I haven't.
Well, yeah.
I don't have any direct experience with the comparison. And Form 1 in particular, their software experience will be order of magnitude more refined.
You said that you have YouTube videos. Do you have anything on like, essentially, how do you determine like the exposure per exposure just through iterative? Like, essentially, because here you have 15 seconds.
There's published ones. So they're on Kudo3D's website, right? Ted has done a lot of experiments with different resins. So for the resins that they've used, he has information about, given the resolution, what should the different layer exposure times be. So he's got guidelines for all of those. If you've got new resin, right, that no one's ever, well, if you've got new resin, exposures may often change depending on the shape of your part too. You may need more or less exposure depending on the properties you need. So like less exposure does make it easier to lift, but increases the chance of warping. So if I need a really, really straight part, I need to cure it more. Sometimes substantially. In order to get this part good and flat, I had to go up from 4 seconds to 14 seconds per layer.
So even that would curve otherwise?
Yeah, I mean, if we look at this guy here, this guy might have been somewhere in the middle. This guy is curved. You see that this guy is curved, right? And this guy also, the support broke on the inside, and so this section here isn't flat. It's bowed up, right? This guy here is flat. Yeah, this is a mold.
For what?
For a flashlight diffuser.
No. Half expecting you to say lightsaber, but.
No. Well, you kind of same principle, but much shorter.
Have you worked with any sealants or stuff? Because essentially the UV stuff, the problem I have with it, so I'm trying to use it for Stanford like UAV design, so for like wings, but the properties change over time when exposed to UV. Do you have experience like coating it or?
Oh, I've never tried coating it. The best I've done is try to bake it as much as I can before putting it into use, so it gets into a stable state. But yeah,
baking it as in UV baking or temperature baking?
I've only done UV, but people have said that depending on the polymer composition, that temperature baking also makes a difference. Because in a highly pigmented piece like this, UV that I shine on the outside is never making it to the center of the part. And so the center of the part is always going to be some difference. And some people have said that on certain types of resins, you can you bake it like 180 degrees Fahrenheit, and that will, and you heat cure it for a couple of hours, and that will settle the resin. But I mean, there's always trade-offs. The more it's cured, the more harder it gets, and the more brittle it gets also. So if your problem is getting brittle while it's being exposed to sun, all you're necessarily doing is accelerating that.
Yeah. Well, I mean, we want it to be stiff for essentially the wing. That you want it as stiff as possible. What we don't want is it to change during use. So we are we're even probably gonna metal plate some of it for fun and for.
Yeah, I definitely have read in forums about people. We've got people doing clear coat to try to preserve the flexible properties of the resin.
Essentially, yeah.
But I don't know how effective that is in the long term.
Unless it's a really good UV blocker.
I mean, there's some quite good UV blockers on the market. I mean, like, whatever is inside of this is miraculous. There's some UV blocker that's in the 3D ABS that is miraculous.
Because it keeps it flexible,
because it blocks UV like mad without blocking the transparency. You can see that this part here looks like it's a lot more pigmented, but the supports have all gotten merged into the part. This one, and you kind of have to take my word for it, but when you look at it, this one came out just like this.
Yeah.
But this is still transparent. In fact, you would say that this is much more clear than this. And there's other, when you look at the side here, right, and you look at the way you see the laser going through there, right, and if we compare to this part, even just looking at the way that it reflects off, right, completely different. There's something in here that is magic. And Autodesk has a instructable where they go through kind of the different chemicals they used, and they use a UV blocker called Meso OB. And that stuff is like also miraculous, and it's very selective. Part comes out clear, but it inhibits curing in really small concentrations, like 0.01%.
So but these things aren't like sprays that you can spray at the end.
No, these were additives into the resin. Yeah.
Okay. Another question: Is there any way to make this wireless the way that essentially you can do Raspberry Pi with like an FDM printer and have it put on a multitude of different software?
You have to go off the reservation a bit. The software that is documented and drives these printers that they send is Windows-based. And so the only way for you to make this wireless would be you get like a cheap Windows tablet, and then you run the control software on that, and you go into like remote desktop or something, right? There is a project on GitHub called Creation Workshop Boost, and this is designed to run on a Raspberry Pi and drive a printer with the same principles as this, meaning it controls the layers based on controlling the external monitor, the HDMI output, and then sending G-code to do the lift commands. And this uses a standard ramps board used for FDM printing. It only has one stepper driver for the Z-axis only, but it takes regular, it's a regular G1 Z command to move the stage up and down. And this, in theory, should be able to. Yeah, this in theory should be able to drive this printer off of Raspberry Pi. I haven't used it before. I have a couple of Raspberry Pis. I keep meaning to try it out, but I haven't gotten to it yet. One of the things is that compared to other printers, mainly because of the way the stickiness works for the Teflon. There's more of a reason to have many different layer settings for this, where you have like an exposure setting from layer 1 and different exposures of 2 to 8, different ones from 9 to 100. And these oftentimes will change with your part design. So if you know you've got a part and it's got changing surface area in different parts, you would align this to where those surface area changes were, try to mitigate some of the forces. This is based on open source software called what's it called? Print Run? Project Layer. And then they modified it to add even more. Project Layer had 4 zones because oftentimes and they added 8 because a lot of added 4 more because a lot of people used them. Most tools, like Creation Workshop, the slicer that Ted was showing, has a built-in printer control. But that only has 2 settings. There's only attachment and then rest of part. Most printers only need 2 zones, one to attach to the build plate and one for the rest of part. Most of these other printers don't need the variation that we do here because of the flexing, especially the non-linear flexing effect.
So that exposure, the ratio between the 2 exposures is like almost 3 to 1. The base layer and then
yeah, usually it's quite big because you want the first adhesion layer to be really hard, because you need it to stick to the bed very strongly, because that layer has got to withstand the sum of the separation forces for the rest of the life of the part, right? So that thing's going to be under stress every single layer.
Is there a way similar to FDM printers to essentially do the wrap on for the part, just make like a big almost adhesion?
Yeah, I use Paint for that. You open up layer 0, and then you draw a big rectangle, and that's it.
On the PNG?
In the PNG file.
Okay.
Yeah. I mean, Creation Workshop has a way to build a base layer. And it will try to figure out what the dimensions of the part are and then go out a little bit. And then it builds like a millimeter thick, which is way too thick. It actually it makes the layer less effective to be so thick, and then you have to dial it back down. I don't do that anymore. I just go into Paint. Yeah, I use a single layer, and I'll go into MS Paint, and I'll just make a big rectangle on that first layer, big white rectangle on that first layer, and that's it.
There's really no software that essentially you just put in those files and tell it this is the layer thickness, and it creates a three-dimensional. Essentially, just checking to make sure that your slicer sliced it correctly. You said
not that I know of. Not that I know of.
Seems like a simple software to design, but yeah, I wouldn't be surprised.
Yeah, I mean, because it had to be, I don't know, it'd be voxel based. It'd be very much volumetric. You wouldn't get triangles back. Some people have wanted to get triangles back from that, and that's really impossible.
These are really small triangles.
Yeah, but I mean, because everything is square. I mean, you could maybe with like a voxel modeler, you could come back and look at it, but it'd be hard because you still have to go through. You have to look at the interior. The interior of the part that's the biggest. That's the biggest concern, especially with interior supports.
When first we get this.
Okay. So if I
to reach 0.
So if my company, so I have my own, my company has, they want to spend to seem more innovative, but if we bought this and used the same resin at the same layer thickness on every print, that should drive down the amount of essentially error, just like essentially my concern is getting something and then having it not work.
Yeah, that's
at a high percentage.
It's a challenge. You're like a challenge there.
Because people, I mean,
without a simulation tool, in my opinion, the chance for an inexperienced person to print a part successfully of their own design the first time is virtually nil.
Yeah.
There are many parts now, when I look at them, I'll say, this is an easy print. I feel confident I can get this done on my first try, right? Because I printed quite a lot, right? So there are things where I could look at it and say, yeah, I can print this on my first try. But if I go back to say January, when I first got the printer, before I put so many hours into it, right? There's no way, there's no way to know how difficult an object is.
You really improve performance?
Yeah, I've printed a lot. I've spent a lot of time on this weekends printing stuff. I print a lot of stuff. Burn through a lot of resin, hundreds of dollars of resin. And that's what it takes. I mean, the problem is that it takes resin and actual printing to build up your knowledge of that, right? And so if you have a resource that you're just going to go, someone's just going to go and print and expects it to come out the first try, never having done it before, they'll have almost no idea as to whether or not they take an easy or a hard part. And when I want a part, I don't want you to say to me, well, that's hard. No one can print it on their first try. You know, when I said it was easy, I was talking about parts like this. A part like this, almost anyone could print this correctly on the first try. Right?
And then you're reaching.
Yes, because I know what you're looking for is maximum single layer surface area. The maximum single layer surface area of any one of these cross sections is a bunch of dots, right? And so I look at this and I think, what is the maximum single layer surface area? How big is the surface area, right? Which means, right, there's a difference in forces on this end compared to on this end. So how much differential is my part taking? In this case, it's very little, right? And more importantly, my part is still a bunch of dots, even as I go up. And so as I go up, I'm not building a structure somewhere that's going to cause the forces from one side to get strongly set to the other side, right? And that'll create the flexing, whatever, right? This part, because it's not two really fine surfaces, super hard, right? Really, really hard.
You have to spread it the long way, you can't spread it across the.
Well, I have to print this, but I can't print it this way. Most people in SLA print it like this, right? You use the axis, you take it 15 degrees this way, take it 15 degrees this way. That
So once you hear that, that's fine. It's a little bit.
then all the different warpings that you get, warping like this, is very like non-linear on this face, right? The chance of this face coming out perfectly flat doing a traditional SLA way is virtually impossible, right? And I know that the flatness of these surfaces is paramount, especially this one. This doesn't meet the other side of the mold.
So if it's
and this
working
mold
okay,
will have like crazy ejections in the filling, right? So I really need this surface to be flat. And that's my objective. I don't know anything about printing. I will know that I need to do something unorthodox to optimize. I'll put on the printer, I'll come out through, and I could get a part out of it, right? I could probably define a procedure where if you follow these steps, you will get a part. But you won't get the part that you want. And getting from a part that I could print out like this to a part where this works, right, where this surface works, which eventually may be coming back down and going into bed and getting the settings to work and stuff like that. Which are really different from the settings you use for this. That's very difficult. There's a big problem. There's a difficulty when trying to get to the stage where inexperienced people can print their objects on the first go. Because there are many objects that are extremely hard to print. And without a simulator, or like we load it and look, warning, this is going to be really hard to print. Are you sure you really want to do this? You'll have no idea. It'll just be failure to failure. You'll have no idea what about this part is different from this part. This part needs to be.
So this is another way.
That's a big problem. Actually, that may be the biggest problem if you wanted to put one of these.
You have
This is the problem solved by the $100,000 those, to a large extent, many of those are push button. But they solve the problem because they have millions of dollars of R&D in their software. Plus, they have carefully that means the rest is
otherwise we would just make it like this and ship it. But the shipping costs are very expensive. And people will price it at the end for like rates.
For myself.
Yeah.
It's literally 10 times as much as
But that stuff is magic. It doesn't shrink.
It's, yeah, it was interesting because just for consistency and accuracy, but the performance is exactly the same. I like in our project we tested two different ones.
Yeah.
That were, like the vertical print and the horizontal print were exactly the same, but on my printer, vertical print was crappy because it's really bad surface adhesion between the layers.
Right.
So that one just snapped, but the horizontal and horizontal function exactly the same on both printers. It's just that one, like you put it in there, it'll be done.
The consistency is there, right? Yes, because in the end, it's still, mostly ABS. It's gonna mostly come out the same.
Yeah.
But there's the shrinkage factors. If I curve components, if I have issues where I don't take shrinkage into account and I have thick walls joining onto thin walls and all that, it'll still work in the Stratasys stuff. But all of these things will affect you in like regular real ABS and regular 3D printer.
Well, thank you so much for organizing this.
So this is, do you know what, this one's just like, do you know how what this one's called? The model?
Oh, I don't know. What's the name of it? What is this model called?
Chiral.
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 Oh, okay. Got chiral.
Just can you search it from George Hart's website.
George Hart.
Yeah, he has a lot of balls there.
Oh, it's a chiral ball.
Chiral.
So this is designed individually, or did he just create essentially a hollow ball and then use software that creates the lattice?
No, he used math to calculate the structure.
Oh, I see. Yes.
But
George Hart Mathematical Art Gallery.
Yes.
Right. So these are he has there's a function that defines this.
Yes.
There's a function that defines this object, and he has executed that function to create the STL models. Yeah.
Okay, because we're also, our wings that we're designing actually look a lot like this, because we're essentially printing a lattice structure that has a hollow center and for the wing, and then you wrap it in a film.
Right.
So it actually probably would be one of the easier things to print.
Probably.
But
I mean, it depends on orientation. You have to print a wing like that.
Well, the idea was
Overhang, you'd have to print it like this. You'd have to know that even if I could fit it on 19.2 centimeters, that if I printed in that dimension, it'd be super hard. Because the software won't tell you. The software won't tell you, hey, it'd probably be 10 times easier if you rotated that, right? Software has no idea. It won't tell you that. And that's,
so the reason that you do the angle in these printing is it works.
it reduces the per layer surface area, right? So if I have a flat surface like this and I print it at massive surface area in a single layer, if I tilt it by 10 degrees, then what 19 degrees is that 19 millimeters can be divided across like 10 millimeters of Z. And then each individual layer is only going to be a couple of slices, a couple of pixels.
But if you turn it 100% 90 degrees like that.
Yeah, I mean there's an optimization function. So this will be like less and less and less and less, and then it'll start to get more and more and more and more, and then it'll kind of max out. There'll be a local minimum, like kind of here in terms of surface area.
But if you printed it this way, would it actually work, or would it would it break off probably because of the lever arm type of?
No, it would.
Because I mean, this is printing vertically is exactly what we want, because it gives a perfect outside geometry.
This would work,
but we were advised against it by 4 people. Essentially, they wanted. To me, it seemed that they wanted the wider base and then the smaller. Essentially, as you get further and further away, you have smaller surface area.
That's correct. You want to have less surface area as you go up.
So if it's perfectly vertical, you would essentially have.
No, I mean if your wing is tapered.
Well, our wing isn't.
Oh, it's not tapered.
It's tapered, but not enough to like notice.
You could. I mean, for instance, if I were printing it, I would print this part first, right? So definitely this has the most surface area, this end has less, right? If I were to print it like this. But I still have a couple of really solid layers here. So I would probably tilt it a little bit like this. And then that's when problems start happening. Because when I start tilting it like this, then this becomes concave. So this edge is built in the middle of nowhere in space. And then suddenly I'm going to need supports coming down to make sure that this edge gets built. Because when I tilt it this way, then I've got a concave surface. This part will start printing in Z before its base is formed, and that creates all kinds of problems. That's why eventually I couldn't get a good way of printing it like this. Plus, the flatness doesn't work out. And that's why I ended up printing it sideways like this. But if it's a lattice structure, lattice structures are very, very resilient because your per layer surface area is just so low.
Yeah. One weird thing that I did when I was putting an FDM, when I printed it vertically, it kept wiggling too much.
Yeah.
So I printed 6 together, connected by essentially tiny little, just like beams.
Yep.
Like micro beams. I guess I could do it. Do you think that would essentially, if you had just like printed 2 of these next to each other vertically, and just connected them occasionally in random spots that were easy to snip off at the end without.
Mesh Mixer has that type of support by default, and those supports work very, very well in SLA because you can have a beam even that's like 3 centimeters, just straight flat across empty space, and those will print fine because the whole layer comes out all at once, and that will. I wish I had an example, but that's pretty miraculous. I mean, it's kind of like how the floor of this object suddenly forms in midair, right? And would form a surface area that could be as good as this or better.
Yeah,
right.
As long as something is supported. As long as
it's a little bit supported in the corners, maybe you could probably put this whole thing, just the whole layer would appear suddenly all at once. You don't have to worry about how does this middle part get connected to the outer part if I have to draw infill or something on FDM. Here, the whole layer appears at once. And so a flat bridge like this, or even like a two-dimensional bridge, comes out really well.
Yeah, well, we did print it, our wing on a Form 1, and essentially printed it at like this angle because they wanted the wider base. But then you have like an excess of material that you're using that you're just snipping off. Essentially just creates all those supports that go all the way from.
Well, I mean, it's difficult to get away from supports. I mean, I lucked out, and this part I can print without a lot of external supports. There are a broken one, right? Yeah, there's a boatload of internal supports. To hold up this roof.
It's a pretty thick wall thickness.
This resin is not very strong. I need a thicker wall thickness so that I wouldn't have all kinds of defects. I fill this with epoxy. So if there's any defects along the edge where they separate, then I'll have a leak, and that's a huge pain because I'll have to patch the leak while there's liquid flowing. So I needed a thicker wall to make sure that the wall got built up strong enough that it would be watertight.
So you actually injected, essentially made it hollow and then injected it to fill it.
Right.
Okay. What?
I used to use a funnel. I stuck a funnel in like gravity.
What type of, was it a dense material that you used?
Yeah, I used aluminum filled epoxy.
Okay.
So this is really viscous stuff that takes forever to fill it. That's why I have all of this stuff on the outside, because I poured it in to the funnel, and then it was just too slow, so I went off to do something else. I come back and like, oh, it came out the air hole.
But have you used, essentially, do you know of any lighter weight, like fill? Essentially, if you wanted to essentially fill it with foam.
When they were 2,000.
I guess you could. You could use the two-part.
The two-part like polyurethane, or.
But those foams, they start expanding instantly. How would you get it down here?
You know, ideally you want to make it so that
you just mix it, right?
And the software
yeah, but it starts as soon as you
expose
mix
the layers. And,
I don't know.
so there's a little
I think you could
less
get it to work.
magic involved.
You could probably, so you know those, my friend, so you know those like the two-part epoxies that you squirt in there? If you had one of those, but at the end it had like a helix that it actually connected them together and mixed them as it
They
goes
sell
up.
those. It's called mixing nozzles.
Okay.
Yeah. So pro two-part epoxies. There's a disposable helix mixing nozzle.
Yeah.
You snap that onto it, and then you gotta get this like $60 gun, right? And you get the gun, and you put the epoxy in, and you put the mixing nozzle on, and then there's a helix, and they mix together as they come out.
Okay.
I don't know about. I've never seen any of those for foams, because foams come in like cans, and they're
still
thin.
have to be able to expose the light through the thicker layer.
You could put it into a square, especially if it were big. This thing was a pain to fill, or was slow to fill, partly because of the lattice structure inside. Slows down the flow. And so if you didn't have quite as many
But if it's too much,
any blockages in here slowing down the flow, probably fill it with foam.
even if you can do
You
it,
have to compute that.
you have to write resin for 35.
You have to know how much foam. Is there a delay? You mix it, then you pour it, and then there's a delay before it expands. So you have to know exactly how much to pour in.
Or have
escapes.
Yeah. More than I have here. It'd be all over.
It would be it would be pretty much the worst if you spent all that time printing it and it just exploded because the foam expanded too much.
You have a tail left.
That would be unfortunate.
So using that tail to explode.
Okay. Yeah, because we're doing that for, we're 3D printing it, we're 3D printing metal coating, we're 3D printing dissolvable and then wrapping in carbon fiber and then filling it with foam. And way too much crap. Trying to find the best method for creating wings for those.
Assuming you don't want to be a chemical business and make your own resins, if you were using
even when you got it like almost perfect, you still had to like sand it to make it.
Resolution limit based on the resin.
This is as printed. This is also as printed. This has the texture of the Teflon at the bottom, right? So one end of the print, when you print it flat, will have the texture of the aluminum build plate. The other will have the texture of the Teflon. So I deliberately wanted this to be the smooth of the Teflon for these to fit together.
And how did you So when it's, how did you get this thick of a thing off the build plate?
It was hard. When Ted ships these, he ships them with steel spatulas. And so I jammed the spatula in the corner, and then one of them I was able to get it just by hand, and the other one, yeah, I used a rubber mallet and just kind of tapped it in. And you need to get it in far enough that you can start to shear it a bit. Once you can move it laterally, then it will come off really easily. That's why there's a little bit of damage here from when I didn't go in quite. There's always
for this resolution.
The build plate is anodized, but the steel is still, if you hit a corner, it will still scratch the anodization. So you kind of want to go in really flat so you don't scratch up the build plate, even though it doesn't really matter if you scratch up the build plate. And I was a little bit, I had my aim a little wrong, and I was aiming into the part, and so I pulled off a piece here. I mean, there are a bunch of other tricks to get this part. This part kept pulling off the build plate. And so in order to keep it from pulling off the build plate, I have supports that stick out this way, laterally outside in parts where the surface finish doesn't matter. Now, I needed surface finish on every single surface. I wouldn't be able to do this. But I said, this part here, the surface finish doesn't matter. The mold is only going to go like this. Sides don't make any difference. So I have a bunch of supports that come like at an angle out from here, sticking onto the attachment layer, and that helps hold the corners on. Because once one corner starts to come off a little bit, that'll grow. And then yeah, and so you really need to make sure that that detachment just never happens. And so that's what I did on both ends, and that helped a lot. Originally, I had fins built into the part. I had fins sticking out for that purpose, and you can do that too. It didn't work for me because my model is the positive diffuser, and then Autodesk Inventor has a mold tool that auto-generates the molds. And because then when I put features onto the mold, if I change the original and auto-generate, then I lose the fins. And so I eventually got rid of the fins because I kept having to remodel them. Whenever I changed, if I change a parameter like size of the stock, then I have to recompute it, and then I'll have to recreate the fin. So I stopped doing that. It's relatively easy to add these in Mesh Mixer. And so I do this every time now, which is easier than modeling it every time.
So you model it in Mesh Mixer, and you have a secondary file that's kind of that, and you just connect to it.
This is generated in Inventor, and then in Mesh Mixer I add the supports.
The only one that has,
How do you like Mesh Mixer? My brother uses
stuff. It's unstable. It's not the greatest piece of software, but it's okay.
Free, right?
It's free.
Yeah. And it's, have you pulled anything off Thingiverse or whatever and converted STL files to solid models?
That's super hard.
Yeah,
that's virtually impossible.
I think would be easy, but it's
no. That because I mean,
it's very expensive.
I mean, you can't change anything. All you can do is change the dimensions or scale it. It's you once you pull it into CAD, it's just one blob.
Well, yeah, but you mean being a solid model blob or a graphic? Because that was the problem. Is that essentially we wanted to build something that had Abraham Lincoln in it, and so we pulled like his face and something off the internet, and then we wanted to combine it with something else. And the problem was it was an STL file, so we spent like a week finding.
Yeah, there's no good way to do that except in Inventor 2016 just came out like 2 weeks ago. They have better support for these external parts, and I tried it just a few days ago. And it works okay. I can put an STL and put it into an assembly, and I just want to stick it in an assembly and just leave it there. That does work. So that's a lot easier now. Otherwise, yes, otherwise it's virtually impossible. The only tool that's very good at that is Tinkercad, but you can't import CAD models into Tinkercad. So you would have to design your whole part in Tinkercad. As the name implies, It's not very powerful.
Yeah.
I designed this in Tinkercad. Tinkercad is browser-based. It's all written in JavaScript. Autodesk required. So I designed this in Tinkercad.
You designed the ripple thing in the middle?
Yeah, the ripple thing in the middle. Oh, well, I didn't design it. Somebody had written a shape generator script.
Okay.
And so if you're good in JavaScript and you think that you can programmatically model something, hey, this thing is great. It's certainly easier to programmatically model something in Tinkercad than in Inventor, I think. But unless you're doing that, it's pretty primitive. So a simple part like this is okay. You wouldn't want to design like a wing, have it stuck in Tinkercad, because you can't export in any reasonable CAD format.
Well, so the reason I asked
I assume you're going to be at
about if this was, you said it was mathematically modeled by something Hart. I wrote it down. Richard.
Rich George Hart.
George Hart. And that's H-A-R-T, not
H-A-R-T, yeah.
Okay. It's because Inventor has something similar to that. But it it's like, have you seen that fab where they create, essentially you put in a solid and it converts it all into a lattice of some kind?
Oh, yeah.
So that's what I was wondering whether, but it wouldn't be this beautiful. It would be essentially layered lattice. It wouldn't be like a spherical lattice the way that this one is. But this is almost, this is kind of what we're, I don't know, a lot of fun, but difficult. I mean, to me, it makes sense that what I'm going to try to do is print two that are vertical like that and connect them.
Yeah.
Because then you get the good surface quality of both. Because when we build like this, everything gets ugly because it's at an angle.
Yeah. Yeah, the angle is a difficult problem for flat surfaces.
Were you interested in the Carbon 3D? Did you see that thing that came out, Carbon 3D?
Yeah, I've been following that a lot.
What have they done? I mean, what have they been in the news besides the TED Talk and the thing that came out at the same time?
Well, the biggest one is people have been looking at the technology and looking at their patent and the reason why it works. And it combines two things. I mentioned before that, right, two major kinds of vats exist today. Teflon floored vats, which have higher stick release, but they're unreactive. And the silicone vats, which silicone has this like non-smooth surface at molecular level grabs oxygen, right, and holds it at the surface, good for inhibiting cure. And what Carbon 3D uses is a type of Teflon membrane called Teflon AF, which is very gas permeable. And so it's a flex vat.
Oh, it is flex.
Yeah, it's a flex vat that has a Teflon surface, so it's tough as Teflon, but air can go through it, and that gives you both the advantages of Teflon surface and the cure inhibition of silicone, and that brings you to a level of.
But essentially, so there's no acrylic underneath it. It has to be completely Teflon.
Yeah, it must be a tension film.
And they can't. I wonder if they're. Well, I wonder if they're trying to move towards like the soft contact lens versus hard contact. Like, can you make it a hard surface?
Yeah, you can make a hard surface.
Out of the Teflon? Or what I mean is like, essentially, if it's soft, there's a certain build diameter that you're.
Well, yeah.
Max out at
if it's tensioned, yes, you have the issue of sag, because then you have to increase the tension and then counteract the sag. But you're moving in the square, and so eventually you're putting so much tension on it that the material doesn't work anymore.
But I guess if the build platform is.
But their printer is small.
Long rectangular. The longest distance is actually.
Large SLA printers are usually built as top-down printers. So huge printers that are like this, that are like as big as this table, they're built in top-down.
So
where the laser is shooting into a vat of liquid.
And the platform.
And the platform goes down. So it works very similar to like an FDM printer. And then you have to have mechanisms to control the surface tension. The surface tension on the top of the humongous vat, right? Imagine a vat that's as big as this table is going to cause this bow in the top surface. And so then there's there's a wiper system designed to smooth that down, to break the surface tension. And the chemistry of that resin is a little bit different too. The chemistry of the resin is what would primarily control cure depth, because now you're shooting down into the liquid. The laser could go an unlimited depth unless the resin itself was inhibiting the cure.
Okay, so even when, I guess that was when I was thinking about the layer depth and the amount of intensity they put in there. So it cures when you have like, we'll just imagine this is like a quarter of a millimeter, it cures this first area first, right? Yeah. And then it continues to cure through it. So does the last part of it, is that hard to cure because it's being blocked by that first part? Or is it not blocked unless it has an inhibitor inside of it? So like most resins wouldn't, the further into the liquid, it wouldn't actually inhibit it very much?
Yeah, because photoinitiator itself is an inhibitor. So the chemical it is. Okay. So the chemical that initiates the polymerization itself absorbs UV and acts as an inhibitor. Mm-hmm. And so there was an interesting paper where they did tests about depth of cure versus speed of cure with different concentrations of initiator. Mm-hmm. And essentially, at some level, you increase the amount of initiator, and it increases both the depth and the speed of cure. Mm-hmm. And then at some point, it starts to reduce, the depth of cure starts to go down, and the speed of cure kind of straightens out, flatlines, yes. Because then there's so much initiator in there that it's also blocking. And then you've reached some of the maximum initiation rate at some level. Okay. And those are, complicated. They're very expensive to run because you need, your minimum startup requires like, liters and liters and liters of resin. You have to have like $1,000 minimum worth of resin in the tank just to start.
Yeah, that was, I guess, but so with a soft Teflon, it was, what was you said Teflon, what was the? AF. AF? What's the AF stand?
I don't know, but what it stands for is it's super, super, super expensive. A sheet of it, 30 centimeter by 30 centimeter sheet of it, you can virtually not find anybody who will manufacture it for you. One guy did, and it was $250 a sheet.
And how big is the sheet?
30 centimeters by 30.
30 centimeters.
Centimeters.
Okay.
Yeah.
At least that's not millimeters.
No, it's not millimeters. Right? So it's yay big, but it's $250. It is expensive material. And then they have some very interesting software in that because you'll notice in their video they speed up and they slow down depending on the surface area, because you need to give the resin enough time to get sucked into. So even though they're continuously building, you have to get, resin needs to get in. It's getting sucked in. And so that also, the software have to take that into account.
So if like the platform was almost in like a piston and it sealed around the edges, would that essentially suck in the liquid into that area? You know what I'm talking about? Or?
I don't think so. You have to keep under pressure. The main thing is that pull up. Yeah, I don't know. Pull up. That action itself should suck in the amount of resin you need, except in the case where, depending on the depth, you sucked in air instead.
Yeah. Well, so when they have a oxygen permeable layer, does that essentially put bubbles in there?
No, it's not that permeable. Okay. I don't think it's that permeable.
So theoretically, they can make a really, if it needs to be intention, they can make a really thin but long print area. Right? Does that make sense? Because the smallest dimension is what defines the tension that you need. But if they're both big, then the middle would sag. But if essentially one is like,
I guess it's possible. Yes, you could. You have control of the dimensions. You can make a film and then pull it off. You want to build really flat objects, and build a special machine designed to to build flat objects. That's an interesting idea. You have to focus a lot on the surface finish of those flat objects.
Well, because that's kind of our problem that we have with the UAV wing is that it's almost too big to fit on a printer. So once we get the actual design down, we have to work on the joining of parts.
This is that other guy, what's his name? Tom? His slow build plate design. He said, I'm a terrible machinist. So I followed his plans, but I'm very bad at machining, they're not to spec. But this is his design. But you notice that I had problems keeping the metal straight while I was cutting it, and so this end here is not. So he had specified very specifically like a 20 millimeter by 20 millimeter square around this, but I couldn't match it. My angles were not precise enough. But this was the idea, and this is a sandblasted surface, which is too rough. I need to polish down this front side. I didn't polish down the whole thing. It's whole catch resin. I should have left it at the original mill surface because it was very smooth when I started with. And there's the adapter. A friend of mine cut that out of on the lathe out of steel. Oh, the angle. So what you do is you put in the vise and you put an angle here to angle it, and then to make this surface here. Right. Yes. And then I take a face mill and just face this off. Right. And the problem is that as I angle more of them, the part that I can hold in the vise is less. The vise grips less and less firmly. So the vise is gripping on this sharp edge, another sharp edge on the other side. The vise isn't holding this very firmly, and then it has to be sticking out enough so I can get the whole surface. And so this end flaps more. And that's where you see the first one were better, but this was the last one, and it was moving so much the metal that as I moved the part in, it was leaving these gouges. It was going way deeper than I intended. And this is a trouble because I can only take off so much metal before bad things happen. So I had to stop because the deflection was too great. Mainly this edge here is too sharp. But that's mainly because I've messed up. This was the first edge I put in. I made it too sharp. That made it hard to hold on to the rest of it. This sharpening edge is necessary. This slope is enough. So I get stuff here, right? I don't need to go this much. I don't need that. I don't need this much slope. So this first, I have way more slope than I really need. And that made this edge too sharp. Having this edge too sharp made it too hard to hold on the piece for the rest of it. So then they got all messed up.
What's the point of it?
So that when you go underwater, and you eventually pull out, you want this to come off. When it's flat, then it holds it all the way up. And then usually I would scrape it off somewhere in the middle. But if it's way up, like 20 centimeters high, then it's like, ooh, it's a balancing act to get it off and then bring it down and then tilt it off.
Why don't you just make the plate thicker so it doesn't actually go under?
Well, it'd be too heavy and too much material. Yeah, you wouldn't really want it that big because you want one thing you could do if you wanted to make it different that is maybe that held lots more material. Yeah. So every time the plate comes above the surface and then goes back in, it'll push bubbles into it. And usually it's not too big of a deal because if there's enough liquid, you're curing at the bottom. The bubbles are being introduced in the top. Mm-hmm. So the bubbles aren't going to go all the way down unless something really strange is happening. But if you only have a very thin amount of liquid left, and then you go out and then you come back in, then you could introduce visible bubbles into the part.
Okay.
And so when I can, I like to